Okay, Aditya, picking up from yesterday, you haven't finished the last question that you picked, right?
Yeah, part B.
Again, congratulations for solving part A. It is a very interesting way of solving it. Right? Please do your part B, like picking up from yesterday, and then I will finish my stuff in 1 minute. Yeah. Right.
Okay. Great question.
Okay, wait. What? Oh, right. Are you stuck, Aditya?
Yeah.
Look, you're using the strategy of left, right? Take this as that. That is a wonderful strategy. That strategy has a very practical limitation. The limitation you see in front of you. If it doesn't change everything, meaning to say, if it doesn't solve all the problem, the left doesn't help. So in front of you, you see the problem as log base yx, correct or not?
Yeah.
That problem, if it remains after take that thing as w, that problem most likely will always remain. So the taking log xy as w does not solve all the problem in one swoop. Therefore, it is going to remain about the same, right? It doesn't solve the problem actually for you. Now, I believe that's what you're facing right now. Any questions so far?
No.
So, can you track back a little bit? I'm not saying that the strategy is wrong. I'm saying that you probably should have set it up better so that in one swoop, whoop, all the problem, so to speak, disappears. You didn't set it up enough. You let log yx still be log yx. You could have set it up better.
So I have to take log x base y as something.
Look, you notice that there is log x, base xy, right? In two places, right?
Oh, just base change.
Yeah, lah, just base change lah.
Okay.
That's always available to you. And that might just cause you to whoop one go. Now, before you continue, do you realize that this is now basically solving a big problem?
Yeah.
Right. And I want you to see the let strategy as this way. It cannot solve a problem partially. It must whack everything or it is a little bit useless. You understand what I'm saying?
Yeah.
Right.
So it's x cubed equals 1.
That is definitely a very good basic law. Yeah. Is that what they want? Looks like that is what they don't want. Looks like it is. Right?
Yeah.
You would notice that you're good after the tick, right? You're very good after the tick. It becomes easy math for you, rightly so. You would notice that you need to think more at the implementing the strategy, right?
Yeah.
Right. Hopefully you can learn that from this question. Now, you still make funny mistakes yesterday, but I can also see that your log is not basic. That's why I feel very weird when you make basic mistakes yesterday. Your log is not that bad. Your log is good, but they are like gaping holes here and there. Like it's very weird. And then the hole sometimes closes and then sometimes opens suddenly. It's very weird to me. Partly because probably I haven't teach you for long, so I don't know what's going on. I'm really not sure what's going on sometimes. Right. Now, that's why I ask you, this is your subjective feeling. Are you ready to move on to another topic, or do you still need to practice log?
I think I can practice myself.
That's a good compromise. Do you know how to therefore get your log questions?
Yeah, I'll use the drive and I have questions in the book.
Okay, all right. Just note that the Google Drive question will always be at exam level. Your book question, just be careful, maybe yes, maybe no.
Yeah.
All right. So I then let the practice go back to you. You will do your own self-practice. And when you have problem, I trust you to come to me with those problems. And you don't just, let it be unresolved. Right?
Okay, yeah.
That will be what people normally do near exam. They have practiced something and then they cannot do this, then we discuss consultation, something like that. All right?
Yeah.
So for logarithm, that's it, yeah?
Yeah.
Right? Okay. Now, what is the next topic to go to? If you are unsure, look at the planner, right?
Yeah. We had functions.
Mm-hmm. Is that what we are going, or is that just because you write functions there?
No, it's because it's in the plan.
Yeah. So the plan remains, yeah? All right.
Yeah.
Now, for functions, I believe the drive doesn't help because the local schools doesn't study function until later, even though function is not particularly difficult. So the drive again does not help. So the slight practical problem is that we have to rely on other sources of questions, right? Do you have them in the form of book or some sort of revision package?
Yeah, I have the book.
Let's look at it. Let me look at it very quickly. Then I can tell you, this is going to be enough for exam, or no, I don't think so, right?
Oh wait, I have a set of exam style questions my teacher gave us for the June holidays.
That would be very nice. Yes, yes. SJI should at least do that lah, right? I probably other schools, maybe not lah, but SJI should. I'm so sorry, you're not SJI. What am I talking about? You're ACSI.
Yeah.
But yeah, ACSI should. ACSI should.
Functions. There we go.
Okay, let me see them very quickly from question number 1. Oh yeah. Oh yeah. Definitely yeah. Oh yeah, definitely. Yeah, definitely. Right. just for your information, the local studies at the JC level, that is year 5. The problem is if I take the year 5 question, they go even deeper. So it's not good either way, right? It's not good either way. Now, this is good. Now, can you explain to me very quickly what is your problem? Let's use question 1. What is your problem, possibly?
I think it's more of a problem with sketching than like solving.
Sketching and solving is different. For example, part B is sketching. Is that a problem for you, sketching?
Yeah, I don't understand like how it works.
Understand. One question, just to make sure, do you have the graphing calculator and you can use them, correct?
Not in A-math.
Not in A-math? A-math cannot?
No, our school said, like our teacher said, there's no graphing calculator.
Okay, so you only have the normal calculator.
Yeah.
So that's why we can say the sketching is a problem. Oh my goodness, I don't have my calculator to assist me. Correct, yeah?
Yeah.
Understand that. Now you say that there's another problem. What solving, or what does that mean?
No, like like I can like find the F inverse and like GF and stuff. I can do that, but I can't draw.
Oh, so in question 1A, part 1, part 2, no problem.
Yeah.
That's what you're saying. How about state the value of X for which F inverse is undefined?
Yeah, I can.
That's the domain range thingy, correct?
Yeah.
That's okay for you?
Yeah.
All right. Then intuition, I'll accept that first and I'll focus on the sketching. For example, sketching B, you're saying that you don't know how to do that, right?
No.
Now, please note that in part B here, please be convinced first, read that it has no connection to part A at all. Please be convinced of that first before we go.
Yeah.
Yeah, right. So now, we will now switch to the other Aditya Jamboard. Okay, we're not going to use the Jamboard together. So which Jamboard will that be?
The 2022-07.
20, right? All right. So I'll leave the planning by itself. It's page 17. Right. Okay, page 17 then. Now this is function. Right. So now, are you convinced that in this question, no connection?
Yeah.
Right. Beautiful. So let me make it very easy for you. This question seems to be, well, let me put it another way. Let me give you another function. So I'll call that H. Sorry, let's not call it H. Let's call that J, function J. Function J is simpler than function X. There you go, something like that. Can you sketch this guy, please?
Wait, are you on the Jamboard? I can't.
I am on the Jamboard, page 16 though. Sorry, page 16. Right.
Oh. Okay.
Right. So I've given you a function simpler than H. There you go. Please sketch this guy on paper quickly if you can.
Okay. Yeah, I'll get my Okay.
All right. Oh, sorry, Aditya. I don't think you have the drawing paper for this question. At least I don't think so. Correct me if I'm wrong. You're supposed to sketch on the blank or the working area, but not a drawing. So they still expect you to have a nice kind of sketch, but not using this. I think.
I mean, there's no space on the worksheet.
True. What I'm trying to say is, in exam, you may have the space, or they may just ask you to use the full sketch, but not the drawing. Like, let me put it another way. Can you request the drawing paper in exam if just like that? Can you do that?
I don't know.
Based on my other experience, people will just draw either on the full sketch or in a really blank piece of paper, which is their working paper, right? So if I'm wrong and you can request the drawing pad, feel free to do so, right? Feel free. Because we cannot just bring our own drawing pad in exam, right? Can you do that?
Yeah.
Yes, you cannot, right? They cannot. I want to use my own paper. Of course, cannot, right? Okay. They probably wouldn't allow that. So why don't we practice using either blank or full sketch, and then if you can use your drawing pad in exam, go for it lah.
Okay.
If you find this to be frustrating, then please ask your teacher. Simple, right?
Yeah, I'll ask my teacher when school opens.
Then we'll know for sure.
I'll do it on my school book.
I'm following. All right. All right. So a very nice drawing. I will copy it. And now I will use it for H. Now, what is the meaning of the two parallel lines?
That means like it's an absolute value, modulus.
Right, right. And what does that mean practically?
It's always positive.
Right. Now, let me ask you something. You know that the x-axis has a positive and a negative, right? You know that.
Yeah.
You know that the y also has a positive and a negative, right? So when you say it's always positive, do you mean that the x negative always positive, or the y negative, or both, or what?
The y negative.
Wonderful, wonderful. Then visually, which part of the graph is y negative? Visually?
This part.
Very good. So to keep it in the simpler sense, I reflect, boom, and done.
Okay.
Right. In the very simpler sense, I think this kind of sketch is acceptable for the teacher because what he wants is more of the points than just the sketch. Remember back then I was teaching you trigo. I tell you that amateurs focus on the graph, but professionals focus on the points. That has always been their focus, right? When you do this line, it feels that you are a professional because you use these 2 points. It feels very professional to me. You understand?
Yeah.
Right. However, he wants more points. So these 2 points, do you see it is already in the key point answer key?
Yeah.
So all they want of you is to just actually do this. Yeah, actually, I think your labeling is fine. I just want to make it very certain. You just label it like that. So they're very happy. What they want is you to label those 2 points to show your attention to points, which you already have attention to. Understand, yeah? So is this a very nice labeling, right? Now, do you have any idea the other 2 points? Where do they come?
At the 5.
And minus 5. Now, why would they want that? Or is that a random thing?
No, because it says for when x is more than -5, more than or equal to -5, or
right,
less than or equal to 5.
I have a question for you. Yeah? The -5 to 5 is to limit the graph, correct? I just want it from -5 to 5, correct?
Yeah.
Now, think about this carefully. Yeah? Does that mean if they want us to limit the graph, then our graph become, well, simpler? Because, I don't have to draw the whole graph. I just have to draw from here to there. Then, my drawing must be simpler then. Correct or not?
Yeah.
Actually, most of the time, that is wrong.
Oh.
Let me explain why it makes our drawing more complicated. Because before there is the boundary, we don't even care where we stop. We just randomly start and randomly stop. It is to our aesthetic preference, something like that, if that makes sense.
Yeah.
But now, since they specify the boundary, then we have to pay attention to the boundary. We have to show our attention. And therefore, we suddenly have to purposely start and purposely stop. I would argue that makes the drawing, of course, more complicated than before. One more time. Before, you just start and stop wherever you want. That's very simple. You understand what I'm saying?
Yeah.
So the boundary, instead of making the drawing simpler for us, will make additional task for us. And therefore, pay attention to that task. Then they give you more marks for that. Something like that.
I see.
Now, could you find the point yourself or do you need help?
I can do it myself.
All right, please do so and please state it in the graph. That means they want you to label -5.8 on exactly that point and so on and so forth. Now, you may need to do some algebra, okay?
Okay.
So yeah, right. Yes, Kyoko, I can see you. Can you hear us?
Yeah.
All right. Now, how do you feel, Kyoko?
I feel better.
Okay. Let me put on my headset. This 2%, I need it. Wait, Okay. Right. So Kyoko, at 1 hour from now, it will be your sister's turn, right? Because I haven't shifted the time. So maybe this is good. Maybe we'll try for 1 hour first, right?
Okay.
And then you naturally stop the tuition, and then just you're not today is not busy that you're not going anywhere or anything, right?
No.
Right. Then after your sister, right, there will be that no, I'll tell you where to join in for another half an hour, right?
Okay.
So I just want you to be more aware of how you feel today and whether you're tired or not, because this is Saturday and Sunday, right? Then Monday is school already. Then I don't want you to feel more tired than necessary, right? Yeah lah, right?
Okay.
So the tuition has been going on for some time lah. Maybe that contributes. Okay, right. So you're still at the P, correct? You're still at the P. Right.
I don't get the P equals to -4.
All right. So let me check with your right. Okay. Aditya, are you okay? Are you stuck?
I'm thinking.
Right. You do need to show your algebra working. You know how to find the points. I think they want you to show how you find the points, not just draw it. That's my feeling.
Okay.
So please show it to me so I can see your presentation. Right. Okay. So okay. So for you, Kyoko, just to check that oh, you erase everything. Okay. Right, okay. So just to check that you did all, yeah, wonderful. What you do is totally wrong. Okay, so Kyoko, this is both a bad news and a good news. Now, you didn't get the -4 before because you did it wrong. Here's the good news. Of course, there's something you did which is wrong, but the real thing is much simpler. So I see that you tend to do certain mistakes like this also. I would like to give you a hint so that you can figure it out yourself. Okay? Right, here's the hint. Fraction multiplication is something that you learn in primary 4 or primary 5, correct? Right. So what would this fraction be? This fraction times this fraction? I'm at the page, Jamboard page 7, yes.
Okay.
Yes, Aditya, not the nicest angle, yes.
I can't see anything.
Here, page 7, no, page 7.
Oh, okay. Yeah, I can see.
Okay, so what is 1/2 times 3/5? You learned this in P4 or P5, right? What's the answer for that? Kyoko?
It's 1.5/5.
1.5 over 5. Oh, no. Let's make it easier. It's 3 over 10, right? Which is coming from 1 times 3 over 2 times 5. Correct, yeah?
Yeah.
Right. Just to make it clear, it's obvious that half of 3 over 5 is 3 over 10. That's also one way to see it, right?
Okay.
Which is to say our method here is correct. Now, you are very certain that this is correct. Can I confirm that first? If you're not certain, this is not going to work. If you're not certain, just do this in calculator, see whether it's correct or not. Right?
Yeah, that's correct.
Okay, yeah. So now, with the help of calculator, you are certain. Now, this is my hint to you. This has always been correct since the day you learned it. It has been for 6 years already that you know this is correct. I think you are doing something different in your working. Don't erase your working, just do a new working so they can compare. So Aditya, again, we're looking for the edge points. They want your attention on the edge points and they want you to find it also. So the question is, can you handle the algebra of modulus? Can you or can you not?
I can.
Okay, because I'm not seeing the modulus. So tell me how you handle modulus. Yeah, how do you do that? Because you have to know that. Yeah, I think you have to know. How do you handle a modulus? Because I'm pretty sure you don't like the modulus.
How do we find, what's the method?
One more time. I think the more appropriate question to represent your what you want here is how to handle the modulus.
Yeah.
Yeah. You have no recollection of how to handle a modulus.
I do. You make one side positive and the other side negative.
I'm not really. How does that work? All right. Could you show me? Okay. Oh, you did it wonderfully. You are correct. This is how you handle modulus. You get two things that represents the reality of the modulus, and as a bonus, you no longer have the modulus. I think that's why you may like it. You handle it properly. This is correct.
Oh, okay.
Then the question is, what do you do with it? The question hasn't ended. This is testing you.
Yeah.
This question is good, isn't it? I like this question. This question is definitely testing you. Definitely. Okay. Kyoko, you're not getting it, isn't it? Kyoko?
I get it.
Yeah. So what is the difference here? What are you supposed to do here with the fractions?
Just multiply the numerator by numerator and then denominator.
Yeah. And I don't think you did that. I think you do something else.
Cross multiplication.
Which, please understand, cross multiplication happens between the sides of the equation. This is on one side of the equation. You're supposed to do the left to the right, right to the left. You're doing it very improperly. What you're doing is wrong, basically.
Okay.
Yeah, clear, yeah? What you're doing is wrong. Don't erase that, please. Don't erase that, so that you know what you did wrong. Then you don't repeat. Okay, do it another place. Okay, Aditya, that is very clear to me that you need to understand something. Yeah, very clear. Now let me copy your working. Move to the left, please. Okay, thank you. Now look at page 16 again. Don't erase it, Aditya. It's a very bad move. Yeah. Don't. You want to have comparison, right? Now, when I asked you to draw this, I wasn't joking. Drawing this is the first step of drawing modulus. Do you see how I handle it? I totally ignore the modulus at first.
Yeah.
And then how do I handle it? I didn't handle it here only, I handle it here. I say, oh, the ones that are negative just go up. I have successfully handled the modulus in drawing, right? So in algebra, it involves making the modulus disappear. In drawing, it also involves that at least for a while. Do you understand?
Yeah.
Now, based on that, I can confidently say to you, this is 2 lines, not 1. Correct? This is 2 lines, not 1.
Yeah.
This line certainly belongs to him because that's how you get it. This is that, correct? This is that. Yes or no?
Yeah.
Therefore, why are you subbing x equals to 5 to here? That is a mistake.
Oh, so I sub in x equals to -5 then.
Based on what? Based on the drawing, I would dare say.
Yeah.
Right. Go ahead. Don't cancel this so that you know what went wrong and what went right. Then we'll go on to the next guy. Okay. Is it okay, Kyoko? Did you find something?
Yeah.
Right. Why do you reject 5? Just checking.
Because they only ask for one value.
Oh, no. Look at the graph. Look at the graph. It is true. I'm glad that you reject 5. I'm glad. Do you know that they can do this? That they don't tell you p equals to -4. They just say, hence find p. And then they give you one more mark, 5 marks. They can do that, very easily. The way they word this question, show that p equals to -4, is to make things easier for us. So, and then they give you one less mark. I think most people will prefer that. I also prefer this. I think better than not giving us the answer key. But they can give you no answer key, and then they will increase the mark. In that case, what will you reject? How will you reject?
Based on the drawing.
Very good. It is always based on the drawing. CG is a visual one. How do you decide that I'm going to reject 5, not -4? What does the drawing say?
Because the origin is here and is
very good. Very good.
Yeah.
That's why. You understand that? That's why. There's a better way of saying it rather than relying on the answer key. Good for you. Now, Aditya, you have found 1 point. You have fixed the other one. Okay, now I'm going to tell you something. Do you realize that it means this is the line of this guy?
Yeah.
Does that even make sense? That this guy is not this guy. This guy, which is this guy, it's not this guy. It's not.
Yeah.
And also, therefore, to draw this graph is to draw 2 lines. This guy and this guy, properly cut off here.
Yeah.
This is always the case in any modulus. In any modulus question, you're actually drawing 2 things, the positive and the negative. You just have to find where the positive lie and where the negative lie, so to speak.
Yeah.
Does it make sense now that for algebra work well, I think you have to rely on the drawing. I think the drawing is kind of essential to guide us.
Yeah.
All right. Yeah. So take this as this is going to happen in the next modulus question. Right? This is quite standard. Right? Now, I'm sure function doesn't just talk about modulus. So are you ready to move on?
Yeah.
Right. Okay. Next question, if you so wish. Right. So does the next question have any sketching thing? Oh, it's the first one. Right. So there's no modulus here, yeah? You're supposed to sketch a quadratic form, correct? A quadratic graph.
Yep.
The range will make it easier or harder?
Easier? No, harder. Harder.
More complex, right? More tasks to do. More has to do. Remember that, oh, more has to, I have to pay attention to that, but they give you more marks. Now, one last question before you sketch. There is a 2 mark before the 4 marks, right? Do you know what that 2 is? That's a very standard thing to do.
Express this in terms of where A, B, C are constants.
That means you don't know that form as completing the square. There's a name to it.
Oh yeah, I do.
All right. Then my question is there any connection to that completing square with our sketching of graph? Any connection or not?
Can help us find X.
Okay. Right.
Because it's like in the quadratic equation.
Let me put it another way. If you don't complete square, can you sketch the graph well or
not? No.
Okay, I agree. Let's see how you do it then. Let's see how you do it. So for 6 marks, right? This is now 6 marks, no? 2, then 4. Sketch the graph properly.
Yeah.
Okay, let's give it a try. If you need help, I'm here to give hints.
Okay.
Right. Okay, Kyoko, how is it so far? Do you understand how I do it in the ratio? Ratio questions in general at the start are always difficult one. Right? It is always a very visual thing to do. And I don't think teachers teach it visually. The good news is you are visual, and I think it is better for you to learn the visual way also.
Yeah, I don't understand that. Yeah.
Yeah, the way you do, you already know that the way you, because you try your method and that is good, right? I don't think it is clear to you what's going on, your method, yeah? Right. However, my method, I give a drawing to you. I say that, okay, I think you're supposed to draw at least, right? Supposedly. Now you didn't draw, I think you best draw. Now, when you say you don't understand, meaning you don't understand my method, right?
Yeah.
All right. So could you at least close the drawing and then draw yourself first? Draw whatever you think will help you. Right? You can draw exactly like mine, or you can draw what you like, but you must draw something. Or you just go to the previous page and draw there, also can.
Okay.
Now, this means in exam, you have to flip pages. You understand, right? Flipping pages is not nice, especially in exam. But not drawing is even worse. I wish they make it so that you don't have to flip pages. It's very annoying. But if you don't draw, might as well don't do. Something like that. Yeah? So please draw.
Okay.
Now, Aditya, I will say very clearly at the start, this completing square is not considered the easiest. This is between medium and hard. Do you remember your completing square?
Yeah.
All right. Then let's see your method. All right, Kyoko, again, I'm not asking you to draw my method. I'm asking you to draw what the question is describing, right? Right. So if you cannot draw what the question is describing, that means there is something that you don't understand about the question. Now you tell me immediately. Okay. Your method does look good. Oh. Okay, Aditya, I'm going to ask you to take a calculator. Okay. Now, you're saying basically that you transform the first line into the last line, correct?
Yeah.
Meaning to say the first line should be equal to the last line. That's what it means. Does that make sense?
Yeah.
So if I choose a random X and I put it in the first line, and then I use that same X, put it in the last line, they should give you the same value. That's the test whether you're correct or not. Make sense?
Yeah.
Now, what's the best random X to use?
3.
No, pi. Whenever you need a random X, just use pi.
Oh yeah, pi.
Just use pi. Now compare the first line and the last line. If it is the same, let's move on. Very good. Okay, Kyoko, it looks like you have, I think, roughly drawn what the question is asking. Now, I'm very curious about one thing. Your starting point, the guy, across E, your starting point there. Would you please also label that first, just to be clear? You can label it what you want, but label it properly for yourself. For yourself.
Yeah, it's not the same.
And I agree with your calculator because I have seen your mistake. You must now find your mistake. Now, you're labeling what? Sorry, Kyoko?
G.
G, wonderful. Right. Some people label it E prime, and that's totally fine. G is totally fine. Some people label it M. Do you know why? Why M?
It's because it's the midpoint.
Now you have a question mark. It is because it is the midpoint? Is it because you are asking about their motivation? Or is it because you're asking yourself, is that the midpoint or not?
Second one.
Oh. So let me ask you about perpendicular bisector. It is perpendicular, what you're drawing is a perpendicular line, correct?
Yeah.
Do you know that you can draw the perpendicular line anywhere, not just on the midpoint, correct?
Yeah.
Then why would you choose to do it at so it seems the midpoint? Is it just habit?
Yes, because bisector means it just cuts into 2 equal sides.
So has it settled your question? Is it a midpoint?
Yes.
Does it matter? That's my question to you. Does it matter that it is the midpoint or not the midpoint? Because it seems to me in your own working, you don't use that at all. Correct? Right? You don't. So does it matter or not that it is the midpoint?
Maybe.
Okay, but at least you're sure it's the midpoint, right? At least, right? At least.
Yeah.
So at least declare that the midpoint first in your own way. In your own way, you declare it. And I want you to do it your own way then. You don't have to rely on my way. I'll explain my way later. What do you think? This is something new injected to your method. That's a midpoint. I wonder, is that important or not? Aditya, you're not seeing your mistake?
Was I supposed to remove the 2 at the start?
I'm not sure what you mean by that, but I can show you something else. Kindly expand this in your mind. Expand this in your mind. What does it become? Jamboard page 17. So sorry. Jamboard page 17. Expand this in your mind.
X squared plus...
Expand, no. 2 x squared. Expand.
Oh, yeah, 2x squared plus 12.
What nonsense are you talking about, Aditya?
Oh, I thought... Oh. So 2x squared plus 24 plus
and
6,
you sense
7.
Nothing wrong with that. You sense nothing wrong with that. Really?
That is wrong.
Okay. All right.
So was I supposed to factor out the 2 from the start? I was.
I don't know your goal. I'll pretend I don't know your method. I know it exactly. I'll pretend I don't know. What I can see is that this is clearly a factorization. This is meant to be a factorization by you, right? And you weren't doing that at all. You just willy-nilly separate the 2 from the x squared, and then you bracket this everything. I'm not sure that is allowed in any way, right? Because this is your intention. This is a declaration of intention. I want to factorize the 2 out. How come you only factorize the 2 out from the x squared?
Oh.
Why do you do that? What is that even allowed?
No.
Okay, then. Again, I pretend that I don't know your method. I just point out this simple factorization. And you're not going to fix it. No, you're going to look at it. So Kyoko, does the midpoint matter or not?
I'm not sure.
All right, then I'll pretend to do it your way, because I'm not really sure what you're trying to do, but I'll pretend that I know. Yeah. Now, one question first. The G is fixed at the mid, correct? Because there's a midpoint now. Now, just to be clear, if the G shift a little bit up, I just shift the G up, it's not at the midpoint already. Does the E shift or not?
Yes.
Okay, if the G shift down, the E also shift, right? Correct, yeah? So I believe in some sense, now Aditya, I think you have to test your, don't wait for me, right? I want you to test the final answer, right? Okay, hopefully this is correct, right? So Kyoko, if the G shift around, the E also shift around. So if the G is fixed, then the E is also fixed. Then I believe only then we can find E lah. Because if not, you'll shift around, correct? So in that sense, I think the midpoint matters because it fixes the E. If that makes sense to you.
Yeah.
Right? Secondly, this is the simple logic of CG. You want to find a point called E. You need two things, right? You always need two things to find a point. What can they be?
Two lines.
Two lines or one line and half a point, which is half a point of E. Now, do you have half a point of E?
No.
Okay, I agree. So you need two lines though? What two lines should they be? Aditya? Yes.
The
Yes.
perpendicular bisector and
the CD, right? Do you have the CD? Just checking.
Yes.
Okay. So at least you have one line already. Then the question is very simple, right? To find E, you also need GE. Well, do you have GE? I don't think so. Can you find GE?
I think I wrote here, but
how can you wrote there if you never even realized the midpoint in the first place? How can it be? How can it be?
Midpoint AB.
Oh, you did. So it matters to you. So you have GE, correct?
Yes.
The GE looks, let me see the drawing. The intersection is at 4. I guess that is very suspicious because this equation tells you that the intersection with the y-axis is at 4. Look at B. B is at 5. That looks very suspicious.
Where's
There, B is 5. That is 4. That doesn't look right. Correct or not? Check something, please. Again, you're supposed to use your drawing, and the reason why you don't do that is because you have to flip around. So Aditya, are we correct?
No, it can't be this, can it?
Yeah, because, okay, again, I'll pretend that I don't know your method. I pretend I don't know method. It's because you already tried to fix it as 36 at the top. Because you have a conception that it will be 6 somehow, but it should have been 3. So the way you fixed 36 was the mistake at the top. You shouldn't have fixed it as 36. Because for x squared plus 6x, you need plus.
Wait, what? I don't get it.
The expansion of x plus 30 squared is?
That's x squared plus 6x plus 9.
You don't have 9, you have 18.
Yeah.
Because you already fixed it as 36 on top, it follows from there. The problem was the 36 now. So I think you have to change the 36 so that you can now get what you want. You're right to say that that's the problem. You're right. Change it on top.
So I make it 18 here.
Yes, 18 and minus 18. Then you'll get the 9 that you want, and then test again. And this is why I think this method, which is standard taught by teacher, is fraught with problems. It's a very practical problem. It's not a very easy method to do, especially in exam. This is wasting a lot of time for 2 marks. The problem is it is affecting your 4 marks. That's the one that I hate the most. If you get this wrong, everything becomes wrong in the 4 marks. That's the pressure that I do not want you to face in exam. That's not good at all. Okay, check first whether you're correct. So how do you think, Yoko? Maybe you are change.
I took like 0 minus -4 divided by 2.
Your formula for midpoint is not what I taught you. As in, you need to use that formula. I taught you very different. I taught you that you can see the midpoint by yourself. Don't rely on the formula. The way you rely on the formula is, by the way, wrong. So look at the drawing. I didn't teach you to use formula. I teach you to use your eye. What will G be? Don't use the formula, please. What is the middle? What is G, which is the middle of A and B? Decide that visually.
-2.
Okay, -2, comma?
And 2.5.
Yes, and I totally agree with you because you still have that skill. Now, your formula of midpoint should follow that because you're strong in visual. You're strong in visual, so I can say that to you. You are wrong in your formula. Your formula say that it's a -2, correct? Comma -2 half. How can that be? That must be wrong. How can G be comma -2.5, right? Doesn't make sense visually. You did something wrong there, right? I'm not even telling you what the problem is. I just want you to realize that you could know the problem by looking at the picture.
Okay, but then like during exam, maybe they want in presentation.
Oh no, they want the presentation. What I'm trying to say is you suit your presentation to what you know is correct, to bad law. You just fix what you this is wrong lah. I just try to find my mistake at least lah. If not, you still cannot use the wrong point. It is still going to be wrong. Cannot be right. Right. So please find your mistake right now. Is what I'm trying to say. Go ahead. Now Aditya is now correct, right?
Yeah.
Now the shortcoming of this method is apparent when things are harder, to me at least. It is hard when the coefficient of x squared is not 1. That always causes trouble for everybody. Yourself notwithstanding. After 3 years of trying to teach this method, I got fed up and I just teach my student another method, which is, I believe, is easier. Would you like to at least see that once?
Yeah.
Right. So this is a very practical way of, handling the problem. I don't like this method because it endangers a lot of marks. It takes a lot of time, and the worst is you cannot even get it right, as with other students. That's why I dislike this method a lot. Right? I've only seen some students successfully use it when it matters the most. Now, let me show you the other method, which I believe will be much less prone to error. And also faster, by the way. So this is what they tell you to do, correct?
Yeah.
I handle the right-hand side, not the left-hand side. Putting it simple. I handle this guy, not that guy. In your method, you try to change the left into the right. Correct? In my method, it's just the other way around. I try to change the right into the left, and I believe it is infinitely easier. So please expand the quadratic for me, please, Aditya.
Okay.
No, for me, just say it up in the Jamboard. Just say it up.
Oh, x squared plus 2xb.
I'll put it as 2bx plus.
Oh, yeah, 2bx plus b squared. Okay,
expand one more time, because you know what? It is not yet looking like the left-hand side, correct? Not yet lah.
Yeah.
Right? So let's try.
Ax squared plus 2abx plus ab squared.
Do you see that I separate the AB square and I combine it with C, just, spacing wise?
Yeah.
Do you know why I do that?
No.
Right. Now, after I change the right-hand side to look very similar to the left-hand side, that one you must agree, right?
Mm-hmm.
Okay. First thing first, done. Do you know
Yeah.
I can do that immediately? And then now I can,
yeah.
Right? So 12 equals to 2AB, right? Which is 2 times 2B. Why? Because, from the top, I already found A.
Mm-hmm.
Therefore, B is equals to 12 divided by 4, which is equals to 3. I found B already, which is what you found.
Yeah.
Okay. Now, how do I find C?
You do the AB squared and divide it by, subtract it from A.
Yeah. Do you think it's going to be easy or difficult?
Easy.
Yeah, I would think so. That's my experience. 2 times 3 squared plus C. So in this case, C will be whatever, right?
Mm-hmm.
Right, that's it.
Okay.
Right. And this will give you the exact answer as that. But I will argue this is much less prone to error and much faster also. Okay, now can I erase my method? Would you like to give it a try yourself?
Yeah.
Okay, are you ready to erase, for me to erase?
Yeah.
All right, so go ahead and give it a try. Going from right to left, the total opposite of your method. Your method is going from left to right. So, Kyoko, you have a new line, right? Yeah, you have a new line. So what do you do with the two lines? Just checking. Why do you have to do Pythagoras? It's very confusing. Oh, you found E lah, basically, correct? You found E, right?
Yeah.
Then you want to Pythagoras because of, okay, I understand. Go ahead. Go ahead. Hopefully you find the correct answer. So it seems like your concept is correct lah. It's just that there's an error lah. And it is because you didn't rely on the drawing lah. So let's see whether you got it correctly. Okay, good. Aditya, you missed a bracket on the first line, okay? Just saying.
Oh, yeah.
Right, that's not the proper bracket at all. Now, again, tell me what is the method of this, what is the approach of this method? We go from where to where? We make the what? The bracket is again wrong. You do the same mistake. You did the same mistake just now. That's just the next time mistake. Right? You make the what?
Make the right into the left.
All right. Give it a try. It's almost there. Yeah, presentation one, you don't do what I do. Presentation one, you just write down 2 equals to A.
Oh, okay.
Right, okay. I don't think they will accept such a rainbow. Right, too messy for them. I hope your teacher is open enough for this method because this method is definitely okay. This is not a shorthand method. It's just that that's not what they teach you. Yoko, are you okay? It seems so close, and yet.
Did I do this wrongly?
All right, show me your E one more time. Show me your E because I cannot see your E actually. Your E is a very ugly number. Oh my goodness. Oh dear. Wow, this is getting harder and harder to see. There might be mistakes anywhere. Aduh. minus 1. Let me see the drawing one more time. Sorry, let me see the drawing. Is minus 1 something, comma 2 something, right? Okay, that is already totally wrong, right? E cannot be like that one. Again, you're not relying on your drawing. E cannot be this, cannot be. The X must be positive, the Y must be negative 1. This is like not going to happen. Okay, Aditya, sorry, you're stopping.
Oh, I did it.
Oh, now I see it. Wonderful. Right. You like this method?
Yeah.
Please do this method from now on. It will always be a reliable one. Would that be okay? You still need to practice it a bit more. Again, I've given up teaching students the first method. I can do it myself, but it is just full of practical problems. So I apologize for wasting your effort on that first. Right? Okay, now that's your 2 marks secured. Now we can hopefully secure your 4 marks. Can you sketch? Yeah. What is the big deal about completing a square form? Why do we spend so much time finding it?
Now we can find the X value, I think, like the X-intercepts.
I think that's wrong. To find X-intercept, you don't use the completing square, you just factorize or even better, use your calculator. X-intercepts are not found by this method. The easiest, definitely not. What if not? Why would you factorize? You learn factorization plus anyway, right?
Yeah.
And that is what gives you intercepts. If that's what you want, this is not the method to go to right? The reason is different. Now, at this
is it?
Now, to draw a quadratic graph, you know the general shape, right? It's either a smiley or frowny, correct? A U or reverse U, correct?
Yeah.
Now, what is important to you in, professional thinking, right? What are the important points in a quadratic graph? To you, that would be
the intercepts.
And that will be the y-intercept and the x-intercept. That's what you mean, right?
Yeah.
You're missing one more.
And
very important. Yeah.
The maximum or minimum.
Very good. Now, pray tell, this completing square form is the best for which point?
Oh, the maximum or minimum.
Yes, it's already staring in front of us. If you know how to use it.
The H and K.
Yes, that thing. Yes. So what is the maxima and minima? You may still commit error here. You see, always scares me, right? Okay, so what is the maxima and minima? Because you do need it, You do need it. Now, Kyoko, are you frustrated enough right now? I'm so sorry to say that.
Yeah.
You are frustrated to keep correcting your mistakes, right? Because in some sense, this method is prone to mistakes. In some sense, CG is prone to mistakes. Correct or not? That's why I keep saying you have to rely on your graph because that helps correct mistake. And yet mistake keeps coming. Right? I don't think that's the nature of you. Yeah, it's partly the nature of the question. Okay, yeah, partly. Yeah. Now, if you're frustrated with your own method, which I believe conceptually is correct, it's just that it has a lot of practical problem. Right? Please understand this. So I'm suggesting you another method. Are you frustrated enough so that you can consider another method? Are you, or do you still want to try your method a bit more?
I think I'll just learn your method, but then I'll correct my method.
Yeah. All right. So Aditya, I'm still looking at the point. Yep. We're waiting too much here. Like we're not going anywhere, Aditya. Yeah. You cannot be working when I say that you work. Right? We have too much of a waiting time. Come on. Never wait for me. And that would be wrong. That is not the maximum minimum.
What's
That
the minimum?
is minus 3, minus 10.
Oh, yeah.
You sure you know what's going on here?
Yeah, because it's x plus 3.
Okay, sure. You are correct, I guess, in the reason, right? I guess. So how are you going to use that to sketch? I'm still waiting for your sketch. Still waiting. Yeah? Now, Kyoko, look at page 9. I have the fresh drawing, right? I'll call this the midpoint because that is the midpoint. Again, I'll just call it that way. And then I will notice that this is E. That should be similar to what you have. Now, notice that I don't even care what the coordinate is. I'm not saying that it doesn't matter, but I think it matters that it is a midpoint. I just don't care about the coordinate. Okay. So this shows how different this method is like, because how can we not care about a coordinate in CG? Isn't that what the topic is all about, right? This is because I use the triangle method, specifically the similar triangles method, which is for some reason very rarely taught and yet is infinitely useful in both EMAT and AMAT. I don't get why teachers don't prefer this. I think it's a very powerful method. Okay, following you, Aditya. Yeah. So if I have decided to use the triangle method, it is because I have seen the triangle. Do you see any triangle right now? The one at page 9. No. Yeah, I don't care about the triangle yet because it doesn't seem to have any connection with E. I will tend to care about triangles which have some connections with E. So when I look at E, because that's my goal, right? Wait, there are no triangles here. So my own prerogative, my own, I have the right to create my own helpful triangles. I have that right. This is the basis of the method. You are to be good at creating triangles that help you because there are many triangles that does not help. Okay, there are many triangles that does not help. So to cut that process short, this is the triangle that I've chosen. That process is actually kind of long. The considerations are I have to try this and I have to try that. However, please note that the triangle is always 90 degrees. Please note that. It's just the matter of where, right? The matter of where, right? So that's the triangle, but remember, it's similar triangles. So it's not just one triangle, it is two triangles at one go. So I choose this and that. It's always two triangles because similar triangles. Right?
I think you taught me this before.
Yes. The difficulty is always the seeing of the triangle. Once you found it, it is going to be extremely easy because that's just how the method works. This is 1 unit and 1 unit, yeah. This line is parallel to that line, so 1 unit and 1 unit, yeah, automatically, right? And then why is this triangle similar to that triangle? You have to prove that. Is that so?
90 degrees.
You have to prove 2AA, so 90 degree and one more angle to show that it's the same. It's a common angle. The common angle and 90 degree, correct? Okay. Right. Then obviously this and this is also the same now. So triple A or double A, that is the similarity of the triangle. Proven, correct? Are you okay, Kyoko?
Wait. So this entire line is just this times 2, right?
What do you mean this time? So yeah, this is 1 and this is 2, no? Because of similarity, lah. So this is 1 and 1, no? Done.
So this triangle is this times 2.
No, not the area, just the length. The length of this small triangle is 1, and the length of this big triangle is 2, 1 to 1.
So then this is 1, then this is 2.
Yeah, also because of similarity, which is why you have to prove the similarity, then you can say that. You cannot just say anyhow, cannot.
Yeah, then it's 1, 1.
Then proven, yeah. Yep. Again, you're a visual person, your strength is there, so I think this method is very suitable. Your teacher will not teach it to you, I believe, and yet it will be infinitely useful. I promise you that. In other topics, some more. So this method is a very strong recommendation from me. Very, very strong.
Wait, just to clarify, to find similar triangle is both triangles need to have like
double A from EMATH, no? Two angles being the same. You cannot say two common, but you get the point, right? Yeah, this angle is equal to the angle. Then this angle is equal to angle. You have to show those two angles, right? That's the easiest way to show it.
Okay.
Right. So the trouble is in the finding the triangle and a little bit of inconvenience in proving it. After that, whack, done. Right. So you exchange one type of method with a very different method. Right. That's what you're doing now. Now, when you're comfortable, erase my drawing and then do it yourself. Okay. Give it a try. Okay, you erase yourself. Huh? Now, Aditya, are you a little bit frustrating? It is frustrated in the drawing?
Not really.
Okay, it seems to be going well though, but you keep erasing it now. Why would that be?
I mean, the shape wasn't very nice.
Oh, okay, all right. Does it bother you that you don't have the x-intercept at all?
I do. I just solved it.
Wonderful, right? Which is not very nice. I'm guessing that those intercepts are just not nice, but that serves as a guide, so it's not a bad thing to have them, right? Even though they are not nice. The shape is great. You do tend to want to draw nice things, so I guess that's not bad. I guess that's good. So Kyoko, to confirm, this is almost 1 hour, right? You are not tired. You are okay.
I'm still okay, yeah.
All right. Then that means after I'll see you in the half hour of 2 hours from now. That will be at 4. Yeah, I'll see you for half an hour in 4. Okay? Just to make it up. All right, but you feel free to remain. It's still 5 minutes.
I actually have another question I want to ask.
Yes, please. Aditya, to make it very clear, that middle point cannot be 3. That doesn't make sense. The middle guy cannot be 3. It must be...
Oh, yeah, -3.
Yes, -3. Wonderful. All right. Yeah, good.
My answer is like very close, but
okay.
X equal to Y equal 4. Then if I put this in the calculator, it's like if you round this off, it will be 2. If you round this off, it will be 4. But then
that means you're wrong.
Yeah.
Okay, let's find the mistake. Yeah. So together. Now, Aditya, your other intercept also cannot be 0.764.
Oh, yeah.
That doesn't make sense. Come on, be more sensitive, right? Your drawing skill is good, but your numbers are a bit off, right? And professionally, you missed 2 points. Professionally, you didn't label 2 more points, which are very important to the examiner. Which are the 2 points? Oh my goodness. I'm sorry. You actually haven't labeled 4 other points. Oh goodness me. Right. That's 1. Yeah, that's 1. You have to label that. And the edge is 2, and then the y-intercept also. Yeah. So be careful. Now, Kyoko, let's look for the mistakes. So
I mean, the y-intercept doesn't fit in the graph.
Oh, really? Because of the range, is it?
Yeah.
What is the range, by the way? So I cannot see.
Wait, the range
is from?
Is -5 and then 0.
That means it is at exactly 0. Must be what?
Oh, yeah.
The edge is the y-intercept. So, okay, but you still have to, right? I already saw the mistake, Kyoko. Saw the mistake. I'm very clear that is a mistake. This is my first time seeing your in this, yeah. So I am concerned, I guess. I'm very concerned, actually. I already saw the mistake. Are you ready to, do you want to do it in this or the triangle? Which one?
Oh, what? Sorry?
Do you want to do the in this or the triangle? You're doing the triangle one.
You can just like explain along the way. I can listen, yeah.
Okay, the in this, your mistake in this question is in the first equation, definitely, and it happens extremely early. I'm giving you that hint. Hopefully you can find yourself. It happens extremely early.
Hmm?
Yes, there, definitely. And I'm not sure that you see the mistake. I want to know whether you can see the mistake.
Okay.
And how can you check using calculator in the exam if you are right or wrong there? How can you check? Yes, Keiko, I can see you, yeah? Please wait a little bit for Kyoko, yeah? Very nice drawing, Aditya. So the other intercept you don't need. Yes, very nice. Very nice drawing. Yes, very good. So is 8x equal to 2 times 4 power x, Kyoko, according to the calculator?
Oh, is it?
It is not. Yes, it is not the same. That is a mistake. Definitely a mistake.
Mr. Phillips?
Yes, Aditya.
How do I find these two coordinates?
Which
like
two?
This one and this one.
Oh, right. Okay. So I think that one. Sorry. Okay. To put it simple, in the previous graph, right? You were trying to find the edges, right? How did you find the edge? You did it correctly.
The previous one.
Refer to your previous working. How did you find it? How did you find the edge?
I sub it in.
Precisely. That's all. No mystery there. As in, no special secret there, right? And so, what must you do here? The same thing, lah. That's the extra effort you need to do, lah, so to speak. Because of the edges that they define. Okay. Now, I would say good job with this one. Between this session and the night session, what do you study?
Who, me?
Yes, you.
Well, I do like science.
All right. Because you're not doing math. So if you're doing other subject, I'm still a bit calm. Why? Because maybe near the exam, you have to focus even more on math. Then I'm okay, because you did other subjects already. There'll be a time crunch near exam. I think exam is less than 1 month, right?
Yeah.
Your math is nowhere ready, and you're not spending a lot of time in math right now. But if you're spending some time in other subjects, then I can take more time for math later on if necessary. If not, then of course, no need. But I think it's obvious that you need more time so far. Okay, so I'm not asking you to do math in the middle. I'm asking you to study and make use of your time, is what I'm trying to say. Okay. Right. Now, if you do want to practice your math, I think your function question are there, so that I think that's good also. All right.
Yeah.
Now, so is this way of giving you freedom suitable for you or not, Aditya? Or am I making you a worse student by giving you freedom?
I don't think so.
Right. Then I'll give you the freedom. All right.
Okay.
All right. I'll see you later then.
Yeah. What time? 7:30, right?
Yeah, for the makeup. So yeah, I don't think you should join the middle one, right? Let me think forward. Yeah, I don't think so. It's too crowded. Yeah, you're gonna do 7:30 to 10:30, which is crazy 3 hour. Right?
Yeah.
Your preparation should be to simply rest right? And let's see what happened Maybe you'll have to stop after 2 hours. Maybe you have to stop after 2.5 hours. Maybe lah. Right? Maybe you will just doze off after 2 hours. Right? Let's see what happens.
Okay.
All right. I'll see you then. Bye.
See you. Bye-bye.
All right. So Kyoko, glad that you found a mistake. I'm sure that you will fix something. Correct. Now, would you mind handing your phone holder to? Yeah, I think you solved it, right? Yeah, I think you solved it. See, say x is now equals to 2 lah, right? Yeah. So your in this is not that bad, but you did that mistake. I'm glad to know. Okay, I will see you later at 4 for half an hour, right? Okay, feel free to ask any question you want. Right? The question that you're asking has been very good lah. It has been exam level, which is why I liked it. Okay, all right. I'll see you then. Bye. Okay, all right, Keiko. I hope you enjoy your time yesterday.
Oh yeah.
Your sister has been a little bit tired.
Really?
Do you notice that? No, you. Okay. Yeah. But she says it's okay lah, because I've never heard of her sleeping until 12, which is what she did today. So I was a little bit worried.
Yesterday we were out for quite long, so yeah.
Right. Enjoying yourself, right?
Yeah.
Because when she come back, right, then she says she's very tired. I was thinking, cannot be because of study, what? Cannot be, right? But she said that she has a busy week, so that must be the reason, right? Okay, so just check on her, as in just to make sure that she is not actually sick, is what I'm trying to say.
Okay.
Right. I don't know her tendency. You see, maybe she's the type that even though she's sick, she still wants to work. Right. That's not what I want her to do. Right. Okay. Right. So, do you have anything today, or are we just doing new questions?
Actually, right. I've been doing a few chem papers, and I realized my chem bonding is rather weak also.
Let's talk about it.
Yeah. Usually, I can't really identify the factor that they want us to compare, because there's like a lot to choose from.
What do you mean by choose? So what do you mean by choose from?
Like we really need to decide what kind of bonding is present, right? And then different factors affect the strength of the bonds also.
You're talking about the sigma bond, pi bond, or you're talking about the angle of the bond, or you're talking about the length of the bond, or you're talking about the shape of the molecule. So which one are we talking about?
Like ID, PD, bond.
Oh, the bonds which are not the bonds.
Yeah,
you're not supposed to call them bonds.
Forces, yes.
Yes, and the reason why, because bonds are reserved for 3 very specific things, which is the ionic bond, the covalent bond, and the metallic bond. Those are the 3 strongest things. Even hydrogen bond is not supposed to be called bond, but well, there you go. Right, so you have problem with the weak forces lah.
Yeah, and I guess bond length can be a bit confusing also. So, I don't know, I just feel like there's a lot of content in chem bonding.
You're saying that, for example, you might not be comfortable with dipoles lah, as a result lah.
Dipoles.
Because PD, permanent dipole, depends on the way you see the dipoles.
Yeah.
Which depends on the way you see the electronegativity, which, if you don't realize the connection, it is very weird.
Yeah.
So I get what you're saying. What do you want? Do you want us to talk about the lecture note again, or just jump to the question? That's up to you. But let's jump to it directly, because you have done your practices, right?
Yeah, I mean, after looking at the answer key, like, it's this factor that they're talking about. Like, I understand what the factors are, I just cannot identify.
Let's see. Let's see what you're missing.
Can't really find any bonding questions.
You mean what you have tried? You already understood. No problem.
Yeah.
Oh.
No, I know the content. I just like when I look at the question and they ask me to compare like different molecules, I don't know what is the basis of comparison.
Correct. If what you have done is no problem, then we jump directly into a fresh question.
Yeah, I'm trying to look for one.
Please do. Take your time. Yeah.
I'm only left with one paper. They only gave us 4.
Yeah, I have more, but in terms of prelims. So prelim question are just the same.
I don't mind.
Just whack the prelim, but you have to choose your question. Just avoid the other topics, but the difficulty will be the same one. So no problem. Yeah. You mean I haven't shared with you, is it? I have not done that.
Oh, the drive, I have.
Yes. So if you want to treasure your last paper, which is I think important for practice, right? Maybe you just use mine. I think better.
Yeah.
So
also tomorrow, I think I'll join the evening one, not the afternoon one.
The evening one. So not this slot, but the evening slot. All right. Yeah. Okay. I guess that's okay. Right. No problem. Where's my GC Camp? There you go. GC Camp. Yeah, there isn't a lot. Now that I think of it, I don't have a lot of chemistry questions. What? Wait, I thought I fixed that. Wait.
Oh, structural elucidation also. Oh, yeah.
How come I have structural elucidation? I'm sorry. I thought that's for OChem.
I study until alkenes already.
No, you won't be doing the structure elucidation because it's just alkane and alkene, right?
I have seen some questions though.
That is just so weird. But you can ask me lah. But the prelim structure elucidation is everything, so you probably can. Don't go there. That's a jungle. So I thought I fixed the problem of not having GCQ. Yeah. Yes, I did solve that problem. So where would that be? Yes, I did solve that. Very good. So do you have in your Google Drive, the one I share with you, what would they call the 2020 JC?
Yeah.
Oh, you have. Okay. Because I thought I didn't have that. Good. Okay, I'm confused on my own file. Guess that's good. Okay. Okay, so which paper are you looking at?
Paper.
Yeah, whose school are you looking at? You're trying to find the questions, right?
Looking on paper.
Right, in the booklet, what I should have shared with you, if I haven't tell me, right, is the 2020 H2 Chem, right? And that is from Kiasu paper. It's very obvious that it is from Kiasu paper. So is that what you have?
Wait. I only see CJC H2 Chem and PJC H2 Chem.
Okay, that is not. Okay, so I'm gonna share with you the complete one. I just send it to WhatsApp if it is possible. I think that's easier for now. My folder is a mess. Where's Keiko? Keiko. There you go. I have not successfully sent it to you. Why are we having trouble here? Right, finally I got it. Okay, I send you through WhatsApp.
Okay.
It takes long. Besides this new problem that you realize, is there anything else?
I don't think so.
All right. Wow, sorry, yeah, still take some time.
Okay, got it.
All right.
Okay, I think question 2 is already a chem bonding question.
All right.
ACJC.
Question. You're referring to paper.
Paper 2.
Okay. There you. Wait. There. Where is hey,
Fluorine and chlorine.
Okay. All right. And then that's the extent because I think we'll have more maybe another question, right? So you're not comfortable with part 1 and part 1, I suppose.
Not really.
All right. So I say this not to surprise you, yeah. I say this not to surprise you. Now, you can probably answer this using your O-level chem. Okay. Yes, I think so. So this doesn't require a new thing in JC. Let's start like this. Right? So he already tell you that Cl2 has a higher boiling point than F2. He's not asking you this, He's not asking you guess which one has a higher boiling point. He's not saying that. If you have to guess who has a higher boiling point and then explain some more, it becomes much more difficult because you don't even know, so to speak, the end goal, right? But this one is they tell you basically Cl2 has a higher boiling point than F2. Then, as weird as this sounds, just match the reason to the supposed goal. This is a very bad way of answering a question, but that is what's happening here, I believe. Right? So this is how I will go about doing it, right? So I already know the goal. I don't know why it is true, but I just to make my sentence coherent to that goal. So one more time, higher boiling point is not gonna be I'm just gonna consider hydrogen bond, PD-PD, or ID-ID. That's just the general option I have, no other options. Are you clear about this first?
Yeah.
Why is there no other option, by the way?
Simple molecular structure.
All right, which is to say the metallic bond is out, the ionic bond is out, and the covalent bond is also out. Why?
It's not a giant molecular structure.
Correct. Simple. So hydrogen bond is also out, by the way. Oh, wow.
Oh, yeah.
Right. So I'm just left with either PD-PD or ID-ID or maybe both. Maybe both. Correct? So if I have both, I actually don't have to talk about ID-ID because PD-PD will always be superior than ID-ID. So I just have to worry about PD-PD if it exists. Now, the difference between PD-PD and ID-ID is very clear according to your lecture notes, right? The difference is that the PD-PD depends on dipoles.
Yes.
Right? So is there a dipole in Cl2?
Is there?
Oh, that is a problem, isn't it? It's automatically the answer is no. How do I know?
They cancel, right? They cancel each other out.
Because yes, let's start with the shape. So I suppose I'm now using JC explanation. So even though I say you can explain with O-level, right? So the JC explanation is you should know the shape of Cl2. Well, O-level also, right? The shape is just straight line, correct? Nothing else. There's no bending on anything, right? Secondly, it's not HCl. HCl is, even though it's a straight line, it's not symmetrical. This is clearly symmetrical, Cl and Cl. No PD-PD.
So ID-ID.
Well, wait. Who knows F2 have PD-PD? Even though cannot be because if F2 have PD-PD, then he will have the lower boiling point. Cannot be, right? Right. Lower boiling point. Right? But just to confirm, the F2 also don't have PD-PD. Just to confirm that first.
I don't think it has.
Right. So all that is left is must be CL, ID, ID, F2 also ID, ID. So that cannot be explanation. Cannot be, right? As in the explanation is something like the ID, ID of CL2 is bigger than the ID, ID of F2. That must be part of the answer already.
Right.
Correct. All we have to do is justify that. How come CL2 ID ID is bigger than CF2 ID ID? That's what we need to say.
Okay.
So can you? That is where you finally cross over. That is, I think, yeah, they don't discuss this in O level, even though they could. So you have to use some JC stuff, which they start to talk about to explain why CL2 ID ID is bigger than F2 ID ID. Any idea?
MR?
Okay, when we talk about MR, we usually talk about, it has some relationship to mass, right?
Yes.
Usually, not all the time. So I don't think you want to be quoting mass here. What are you trying to say with MR? Of course, the MR of a CL is greater than F. Correct, definitely. What are you trying to say?
The electron cloud is more polarizable.
In where?
As chlorine.
Because yeah, I think we have to chase to that point because
they don't require us to write that most of the time.
You're very sure? Very sure. So let me just go a little bit further and just confirm whether you need to or not. Well, because CL is bigger than F. In the sense that CL2 is bigger than F2 because you have more what do you call it? You have more You have more orbitals. Right? You have more orbitals. So the outer electron, which will do the ID, not the inner one. The outer electron, which will be temporary polarized, your ID, ID, is further than the center because bigger. If it is further than the center, it is more easily disrupted or pulled towards, temporary pull, if that makes sense. So, voila, look. Now, are you supposed to go to that point or no, according to your notes and tutorial?
Usually no, but they don't really explain what polarizable means either. So I think now I understand.
The pulling here and pulling there.
Yeah.
Temporarily. Yeah. So it's just a temporary disturbance because, for example, they are closer to each other. It is as simple as that. Or they are knocking on each other or things like that. Right? Things like that.
Okay.
Yep. That's your the ID, which is again always temporary. Now, did you think like how I think? Like, this is not, this must be it. But why?
I don't think that way. Actually, when I saw this, I thought of PD first because I kind of associate group 7 with PD, I think.
Which I do try to think about. And after I think about, I eliminate. So that at least you have to do, and well, in that sense, you didn't do lah. You didn't do lah.
Yeah.
You didn't understand the fact that there is no permanent dipole.
Okay.
Right. That is always the crux of PD. Oh, there is a permanent dipole, or there isn't a permanent dipole, or then ideal tetara.
I see.
So that's one important gap, right?
Yeah.
I'll leave you to the sentencing. You can look at the answer key.
Yeah.
You can look at note. Right. So I should think that there are other questions that talks about bonding in this paper lah. Shall we try?
Yeah. Okay.
To find it. Okay. Let's have a race. See whether we find it. Oh, it's a prelim. My goodness, we have to skip a lot of questions. Right? Yeah. Yeah. No. Oh, this is a prelim question. This will take us some time. Right? Oh dear. So you don't have a revision package specifically on chemistry bonding, chemical bonding.
Oh, don't have.
Topical one, I don't have. Okay, right.
Don't
Yeah,
have.
okay. We might waste some time. Okay. If you can find it, good. I'm moving on to the next paper already. Okay, all right. So the next, if you haven't found it, why don't we go to the next school? It is question 4, I believe, of the paper 2, which is in page, which page is this? Show me the page.
Okay.
Show me the page. 159. Okay, I believe that is something that you want to practice. Okay? So you may not know what's a cyclohexane. You may not know that. That might be a trouble. That may not be.
Actually, I think I know what it is.
Wonderful, wonderful. Because they like to do this in exam. Even you have not studied cyclohexane, they just whack you with cyclohexane. And they don't even give you a picture or whatever. Right. Okay, so cyclohexane it is. Already, triiodide ions has a linear structure. Wow. Wow. Okay. Now I know. Do you think you can draw a triiodide?
Linear is in what, straight?
Yeah. It's not a triangle, right? You would probably expect that, but he tells us it's a linear. Then we have to fit things in. Interestingly. Right. This thing happened.
Yeah, I'll just write it in the chat board.
Right.
But most of the time, I don't really have any problems with dot and cross now.
Right. Will this guy give you problem? Like you can opt to not practice this. That's up to you. Yeah. Because I think the bonding one will be the next one, I think. Okay, equals Jamboard will be page 3. How interesting. Yeah, okay. A triiodide is linear. Wow. Okay, how interesting. I is group 7, right? So what does that mean? The one of the I will have 10. Will have 10. Really? I can do that though.
Yeah, I can do that.
Because the bigger you are, the weirder you get. So I guess the middle I will have 10 then.
Oh yeah, about that, right? Which elements can have like more or less than 8?
You may not like the answer, yeah? So the simpler ones, that means the one without, okay, when I say simple, I mean, sorry, let's just go for S. Now, S is a very common example that you say, okay, oh, really? You can suddenly be 10 and 12, really, as like something like that. S is the start of those weird things, correct?
Okay.
So when you look at the periodic table, what is S? Like how many orbitals does S have? Something like that. Yeah, you don't have to remember it, but if you can, then that's great. So 1s to s, then.
Oh, okay.
You can look at the periodic table if you want to. All right. So the key here is 3 low.
Yeah.
The moment it is 3, you have the option of D, right? That's what you learn. Whether the D is empty, but I know then, therefore, the D is there. No? So keep it very simple. If you only have 2 until 2p, there will be no hanky-panky stuff. But the moment you have D, all sorts of weird things happen. The 8 and the 8, 10, 12, right? But it will never be an odd number, just 8. It will never be an odd number. And 12 is the maximum. So 8, 10, 12, no? Those are the options. The options are not unlimited. You don't deal with 9. You don't deal with 11. You also don't deal with 7 with 6. 7 is a very weird, peculiar thing to carbon monoxide, for example, I think. And ozone also, I think.
And then
So,
what about nitrogen?
Nitrogen will not go beyond 8, keeping it simple.
I think it can go less, right?
Less, which is 7, not 6 also. It's weird. Very little go to 6. The 6s are the group 3. It's very weird. Boron can go 6. It's again, it is weird. But 6s and 7s are so rare that you simply memorize them because they are very specific behaviors. You don't get to logic them, right? The 6 are stable. The 7 are usually very unstable things. Again, you simply memorize when they happen and on what, because it doesn't happen on everybody.
Okay.
Whereas the 8, 10, 12 is common for things which have D, keeping it simple. And again, there will be no 11, there will be no 9, and definitely they won't go back to 7. They will go 8 and above, but only even and only up to 12.
Okay.
Right. So why is that so? Actually don't know. These are all experimental results. They kind of just show that it is so. And then we have to invent explanations that make sense. That is basically a researcher's life, Lou. Okay. We know that it is probably 7. Why? Yeah, the problem is we cannot even see bond. You cannot just put molecule under a microscope and see their bond. You cannot even do that. So they have to do all sorts of weird things just to show. And the result is you memorize them.
Okay.
So yes, you do memorize, right? So back to the triiodide. So iodide is definitely a very big, so it will allow 8, 10, 12. So I'm not surprised if the answer just include 10. And I'm also not surprised if there are variations in the internet. Maybe one is this and one is that, because sometimes nobody is sure. Sometimes, right? People have to do a lot of research and just simply look into it and say, oh, maybe it's this one, maybe it's that one, maybe. Right. So again, what I'm trying to say is don't put too much thought to it. As in, if you are wrong, look at the answer key. Okay, I learned from the answer key. Okay, maybe your answer key is better. Okay, maybe nobody knows for certainty 100%.
I see. Okay. So I guess I'll just draw something like that.
Yeah, right. I'm sorry. Yeah. Okay. Right. What? Sorry. What? Well, I don't see the I. That's one. Sorry. Do I have a Jamboard problem? Okay. Let me refresh. Oh yeah. I do have a Jamboard problem. Huh? Oh, I wouldn't have put it that way. Yeah, I would put it slightly differently. So the X belong to the middle guy, right?
Yeah, yes.
Yeah, I will put this as X, right? Because again, originally it will be 7 and 7, right? 7 from the left, 7 for the middle. So 1, 2, 3, 4, 5, 7, right? And then I'll put this as a dot. So that one's from the right. I'll probably put it that way.
What's so dative one? Wait, what?
Maybe. I don't know, actually. Actually, I don't know. I don't think it will be a double bond, though. I don't think so. Because double bond cannot do the reversible thingy. Like, is that a dative bond? Does it become 10? To be fair, I'm not sure that people know. How come there's an X there? Sorry, what? Okay, no.
Of course, got the
extra
electron from somewhere else.
Oh, no, it's okay. But yeah, is it important to show that?
Yeah, we use the
yeah, I guess so. Yeah, the position of the electron doesn't matter. So, but yeah, I guess you can do that. Of course, that is from a donation of somebody else. Yes, true. Right. But do I know for sure that it's a dative bond or not? I don't know. But am I certain that it is not a double bond? I am very certain because double bond don't just break like this.
Okay.
Right. So yeah, that's my best guess. I have no idea actually. But I can see why this is linear. Oh, yeah. If it is linear, then the left and the right must have a symmetrical electron. Yeah, that makes sense. Because if it is not symmetrical, it will be bended somewhere or the other one.
Oh, yeah. Okay.
Right. So I guess that this does take that into account now. I'm not sure whether it is fully correct, but at least it feels like it's going to be linear because fully symmetrical. The middle guy have 10. Okay, lo. So again, we can say that it's not going to be 9, 9. No, definitely. We're going to avoid the number 9, right? Yeah, we have to make the connection between I minus and the I2 kind of easily broken. And I think this is the best way to do it, I think maybe. Yeah. I will make the connection between the left eye and the middle eye harder to break, and the guy on the right easier to break. I think I would do that. Yeah, I think this is my best guess. But do I know I'm correct? I don't. So you feel free to look at the answer key if you want it. Okay. Now, what you're interested is probably part 2 there.
Invisible as in insoluble, right?
Yeah. Do they ask you that? Why certain things are not soluble?
Yeah.
Okay. All right. So how's your thought process here?
This one, they did kind of give us a thought process. So they asked us to figure out the interactions between the solute, the solvent.
Correct. Which is just like figuring out the interaction between ClCl and II, for example, right? FF, for example, right? As in Cl2 with Cl2, what's the interaction? F2 with F2, what's the interaction, right? So cyclohexane with water, they don't interact, correct? They don't want to get near to each other, so to speak.
Yeah.
Why would that be, according to you?
Cyclohexane is non-polar. Water is polar.
True. Cyclohexane has no permanent dipole, right? That's what you're saying, right? No polarity.
Yeah, no PD.
Okay. So again, let me think. Yeah, wait. Let me think for a while. Yeah, I guess you can say that. Yeah. I mean, it has to be symmetrical, right? Yeah, it has to be. All right. So then,
But they form ID here, right? Because cyclohexane is non-polar.
Right. So obviously, when you are non-polar, the only thing left is ID, right? The only thing left. When you're polar, like water, either it is a PD-PD or a hydrogen bond. In this case, I think water usually goes for hydrogen bond if possible, right?
Yeah.
Now, there is one additional thing about miscibility, which is solubility. Like, to be soluble, their bond must be the stronger one of the 3 options. ID will never produce solubility.
Okay.
Because first of all, I think it is not permanent, if you can take it that way. No matter how much ID you do, I think the separation is imminent, so to speak, because to not be dissolved means to separate. Meaning to say, I would rather interact with myself. I think cyclohexane will rather interact with cyclohexane than with water. So you separate. So I don't think ID will play a part in miscibility at all. So even though cyclohexane has the potential to do ID, everybody does that, you cannot use that as a reason for miscibility.
Okay.
Putting it simple, if there is no hydrogen bond, miscibility is already very difficult. Then you don't have PD-PD some more. At least PD-PD can be rather strong, right? you also don't have that, then that's it. Look.
Okay.
I mean, PD can induce ID, right? PD ID, yeah, that's not strong at all. That's not permanent, right? It's induced. It's just not happening. So like that. So things don't normally are visible, is what I'm trying to say. They don't normally visible. There must be a strong reason to do that.
Okay.
Right. And probably we have to go for the next paper.
Yeah.
But so far, what we're discussing seems to be what you need.
Yeah.
Okay, all right. So we're plugging gaps, all right? Yeah, those are all OCams already. Okay. Okay. Now, just to confirm, in I think paper 3, page question 5, which is page 195, would you kindly check that? This is not what you have problem with.
Hang on.
Page 195.
Oh, I have problem with this also.
Okay, all right, okay. Let's look at it, and yeah, it's not very long. Can I leave the explaining the meaning of the term to you?
Oh yeah.
You can as a key, you can look at your notes, yeah. Right. So I think the understanding is more important. So for some reason, they give us all these bond energy values. You do know that you can also get them in the data booklet, right?
Yeah.
Right. So it is important to be familiar with what's there. So at least scan through in the exam, right? Just to be sure. Now, I don't know why they talk about pH suddenly. That must be what they like. Why are we talking about pH? Why? I thought we were talking about halides. I have no idea why I talk about phosphorus, right? Okay, so the pH bond energy is approximately the average of between the HH and the PP. Sure. However, the HCl bond is higher than the O. Okay, all right. All right, okay, all right. Yeah, I have some idea. I have some idea about this one. What do you think?
Are they asking us to compare HCl and pH? Oh.
Yeah, right. Basically, right. So because they're drawing some parallel, right? A, C, HH, PP, HH, CL, CL. HCl and HP should be, comparable. They should behave similarly, is what he's trying to say. But they are not behaving similarly. Why?
Is this electronegativity?
I would think I would go there first. I would go there first. Because electronegativity between an electronegative guy and a not electronegative guy, right? Right?
Yeah.
Will cause the bond to be very strong in that sense. Okay. Cause the bond to be very strong. Yeah, wait. Yeah. Yeah, right.
I'm not sure where to go from there though.
I'm sorry?
I'm not sure where to go from there.
Oh, I mean, if electronegativity is the reason why the bond is stronger, right? The bond energy is higher. So I should say that instead. The bond energy is higher, then actually it just follows. That's it. Because the electronegativity affects the electron distribution, right? So it means that I'm greedy for your electron, which is not mine. Cl is greedy for the electron of H, which is not originally his. Correct?
Yeah.
It makes Cl more negative. Simple, right?
Yes.
And it makes H more positive due to that greediness of sharing. our sharing is not equal. Our sharing is very unequal, right? So your nodes in JC will go towards something like this. This is supposedly a covalent bond, but it has an ionic characteristic.
Oh, okay.
Ion bonds are the strongest bonds. They don't say this absolutely, but that's practically it. There are some covalent bonds which can be stronger than ionic bonds, but ionic bonds are basically usually stronger. So even though you started off as covalent, but your greedy sharing causes you to be like an ionic. Therefore, you are stronger. So pH obviously have the characteristics also, but P is, less greedy than Cl for the electron of H. So you are still more covalent. That's why HH covalent, PP covalent, HP also covalent, kind of. So you take the average, kind of. They are kind of covalent.
Okay.
But HH, ClCl covalent, HCl is not covalent. So if you really want to go there, you can. It is a covalent bond which already takes an ionic character. So you're stronger. You have more bond energy. Sorry. Let's say that. Okay. All that much for 1 mark, but we're revising the notes. Okay. The thermal stability of hydrogen halides explanation, I think, is also connected to all that.
Okay.
Right. Do you want to talk about that?
Sure.
So I don't think it has anything to, does it? So basically, hydrogen halides means HCl, HBr, from HF, HCl, HBr, and HI, right?
Yeah.
Okay, so this one, they don't tell you how it varies. So it's slightly harder, right? You have to predict how it varies, and then you have to justify. The previous questions, they already tell you the goal. So you only think of how to justify, not the goal itself, right? So any idea how HF, HCl, HBr, and HI, this fancy word thermal stability, vary down the group? What is that supposed to be?
This is talking about the covalent bond, right? So, wait.
I
think should be
don't
inside.
think so. I don't think so. Because you should have realized that hydrogen halides covalent bond are not very covalent.
Oh.
They are very ionic. Just saying that first. They are very ionic in their nature. Like HCl is very ionic for a covalent bond due to electronegativity.
So
Not sure. Yes, go ahead.
Electronegativity decreases down the group.
That's what you memorize, meaning to say, because we have no idea, we have no concrete idea how this guy is more electronegative than the other guy, meaning we don't have no concrete theory on why, but we know who is more electronegative. And that is something that, because they don't give in the data, do they give in the data booklet? Sorry, do they give that?
Electronegativity?
Values, yeah.
No, but they say fluorine is the most electronegative.
Correct. And they somehow give a random number called 4, right? And then basically they ask you to memorize the 4 top one. F, right? And then O. And then tied in third and fourth position is Cl and N. Some people say N is number 3, Cl is number 4. Some people say the other way around. Those 4 are good to know. F, and then O, and then Cl and N. Right?
Yeah.
It is also very good to know where H and C is. That's about what I would recommend you to do. If you don't know, I suggest that you Google them and see what is the electronegativity of F, O, Cl, N, H, and C. And you write it down for yourself. And then let's see whether this has any connection with the part 3. right? So if not mistaken, C is like 2.5, is it? And H is 2.1 or 2.2, is it something like that?
C is 2.5, yes. Hydrogen is 2.2.
All right. And
3.98.
And there isn't a lot in the non-metal category which is below which is below hydrogen. Most non-metals will be slightly above 2 hydrogen, correct?
Yeah.
Then below hydrogen, they exist. They are almost always metals, which is to say metal really, really, really don't want to take your electron, right? That's just what he's saying. That's not a surprise, right? Metal really wants to give electron instead. He's willingly giving you his electron. Take it, man. Something like that. Now, H as a 2.1, which is around 2, right? This is a very random number. 2 is a half of 4. That's like symbolic in saying that H has the capability of being a covalent bond, right, with himself, with oxygen. But he also has the capability of being almost a positive ion and almost a negative ion. He can do both. He can do 3. He can do 3. He's a very unique guy, and H only can do that lah. Right? So if people comes to him and say, I want to take your electron, he will give it. 2.1. He's not greedy for other people's electron, but it also means that he's willing to give his electron to other people. Right? But if metal comes to him and say, I want to give you my electron, he is also willing to take the metal's electron. He's willing to do both sides.
Okay.
I'm telling you a little bit of story of H because it will matter sooner or later. I don't think it matters right now for you, right? But what I'm trying to say is electronegativity can paint a picture of how things interact. Now, C is slightly above H, right? Something like that.
Yeah, 2.55.
So C will still take H's electron in the bond, but in a very small way, in a very small kind of not so greedy way, right? And then when the greedy ones bond to C, well, C will also be taken off its electron. So C is also kind of flexible there. So those are the important things. Now, back to our question, do you think this has anything to do with the question itself? I keep asking you, what does thermal stability means? What is he aiming
Whether or not
for?
it decomposes under heat.
Right. That's what usually we talk about in a very specific thing called carbonates. Because carbonates may decompose or may not, right? Then they ask you to explain using our limited language in O-level. It's so difficult to explain it properly, right? I don't think hydrogen halides decompose in that way. It's already simple enough. Carbonates decompose because it has the ability to release CO2. That's about it, right?
Yeah.
HCl do not release Cl2 because HCl is more stable than Cl2. Why would HCl be Cl2? Right? Cl2 is less happy than HCl, correct or not?
Yeah.
It is reflected in its stronger bond energy. So HCl is happy to be HCl and don't want to be Cl2. So it cannot mean that HCl will decompose to Cl2. I don't think so. I don't think so. It doesn't mean HF will decompose to F2. I don't think that happens practically also. I don't think that's what it means for thermal stability. I might be wrong, but I don't think so. Let me think for a while. Can HCl cross the barrier of such? I don't think so. That's a rather big barrier. Even by heat, I don't accept that they do. Because HBr releases Br2 fumes, right? They do. No, wait, Br2 releases Br2 fumes. Oh, goodness me. Let me just check. Yeah, I don't think so, right? Yeah. Yeah, I don't think so. Yeah, I don't think that's what they're asking. I don't think so. Yeah, I don't think so. So what do you think thermal stability means then?
The only other thing heat related that I know is like heat, a melting point, boiling point.
Although I might be wrong, but I also inclined towards that lah. I'm so inclined towards that. So do you, because you would know the comparison of solid liquid gas between F2, Cl2, Br2, and F2. That's quite normal, and I2, right? That's quite normal, right? Correct.
Yeah. Yes.
But do you know the solid liquid gas comparison between HF, HI, HCl, HBr, HI?
I don't think so.
Right, I don't think so too. Do you also know that HI usually form a okay? How come this gets more complicated? Is it? Am I thinking this wrongly? How come we have to go to reversible reactions? Let me think about it. I'm not sure what they're aiming for currently. I'm not sure. How come we are being very fuzzy here? So yeah, that's me understanding.
Yes.
Right. Where are they going with this? Right, I'm looking for the next question. Just curious for the trends in periodic table, ionization energy trend, those kind of stuff. You okay? Yeah.
Should be okay. Yeah.
Right. However, in the CJC question, paper 2, question 1, very quickly afterwards, there is the electronegativity and then predict the structure and bonding also. There is connection between electronegativity and somehow the structure and the bonding. Yeah. And then the comparison for the melting point. Are you okay with this one?
Yeah.
Mm-hmm.
We calculate electronegativity difference and then predict structure and bonding.
Mm-hmm. Mm-hmm. Right, your data booklet don't have electronegative value, right? Yeah, correct. Right? You don't have. Right?
I don't think so.
Yeah, that's why I tell you the thing about H. H is, almost in the middle, right? 2.1 in the middle, right? Between 4 and 0, 2. That's a borderline, no? That's a borderline between things which tends to want to become more negative, right? Because they are greedy for other people's electron, right? Right.
Yeah.
Above H, and then below H are things who tend to want to give up their electron. That means become a positive. I know H is not here, but just by saying that, I think it's already giving you a very good prediction of the bonding present in the O2. Very likely it is
ionic.
Because you would be very tempted to say that it is covalent, right? You would be. I'm guessing lah. I'm guessing without thinking about electronegativity. I'm guessing. If not, then good for you. If you have another good reason to think of it as an ionic bond rather than a covalent bond, I would be very happy to support that. So again, what do you think? Are you reasonably convinced that this is going to be ionic and not covalent?
Yeah. Okay, no, if it's below hydrogen, like it's 1.2 below hydrogen, right? So I guess
Yes.
it's going to lose
one to be positive. Yeah, lose electron. Yes. And O is never going to lose its electron. He will only lose it to F, which F is never in the picture. We never talk about F1. O is basically the practical king because F is very dangerous.
Okay.
It's very clear that D with O will be who's going to be who. Clear. Right? This is not going to be a covalent with an ionic characteristic. This is just going to be straight up ionic. Right? So they throw in the Na to help you, towards that conclusion. Right?
Right.
Right. Now you see why the bonding first, then the structure. I don't think it's the other way around.
Yes.
All right. Because the English seems to suggest that think about the structure first, then the types of bonding. Then if I think about it carefully, I cannot do that. I have to think about the bonding first, then the structure. Okay. So granted that this is not going to be a simple covalent, but probably a gigantic ionic, then voila, right? Okay.
Yes.
And as a result, from O level, you now know why it will connect to the melting point, right?
Oh yeah, this one I should be able to.
Right. Because I don't know what's A. A is from part 1. Okay. Right. Okay.
Oh, what is a nucleophile?
Oh, right. So because you know the meaning of phile, right?
Not really.
Right.
Philia.
Philia, yeah. Philia. That philia is in philic or philia. So which is to like. To like, lo.
Yes,
like. Yeah, to like. So to like or to attract or to be attracted. I think in the world of chemistry, to attract and to be attracted is very difficult to say who's who, right? But the point is, he will like nuclei. So the question is, what does the nucleo means? It's not to attract a nucleon. No. That's not what it means. So, for example, an electrophile, right? That's just the under one, a nucleophile or electrophile. Those are the two things, So electrophile also does not mean to attract an electron. It means something more general, to attract something which is negative.
Oh.
And usually smaller than the attractor. That's how they define who's attracting who. Because it's easier for the small guy to move and be attracted, something like that, right? So nucleophile is not to attract a nucleon or a proton, so to speak, but to attract a positive thing, whatever that positive thing is.
I see. So electrophilic addition, right? The carbocation ion is electrophile.
because obviously it is a positive thing, right?
Yeah.
Which will attract a negative thing, which is usually smaller than that guy, because a carbocation is usually within a very big thing, kind of ish.
Okay.
Right. Yeah. So that's the human term lah. That's a very human way of seeing it lah, right? I guess. Before I mislead you, big or small is a relative term. Just saying.
Oh.
It's big or small relative to the other guy. So.
Okay.
Right, just saying.
There's another thermal stability question.
Where is that? Where is that?
This is page 303.
Oh yeah, I'm there also, right? The CaCO3, right? Which is a continuation. Never mind, let's read it. Calcium nitrate, calcium acid, no surprises, decompose easily, that's O level, right? Then nitrates, and now he adds something new, which is the nitrates follow a similar trend. Oh, I don't know that. Okay, you're going to tell me that. Sure thing, right? So write the equation of thermal decomposition. This one is something that you know, right? Okay.
Oh, yeah.
Right. So he already tell us that group nitrate will follow a similar trend. No? So what is the trend of the carbonate, right? Down the group, which group? Or group two, right? So do you still remember the trend? Because this is kind of half memorization, half understanding, I guess.
Wait, so we're using, are we talking about decomposition or like melting point? So decomposition.
So this one I'm very clear for CaCO3. We should talk about the releasing of CO2 lah. Basically, that's the decomposition, and that is also the stability lah.
Too much.
Yeah, this one clear. So nitrates, meaning nitrates.
Okay.
Yeah.
So lattice energy. Wait, melting point.
No, not melting point. No. The thermal stability will refer to the thermal decomposition. So if you decompose easily, you're not very stable, right? And the decomposition meaning to say you release CO2 for carbonates. So for nitrates, I am guessing, right? I have to make a informed guess, right? It releases NO2 or something like that.
Yeah.
So it releases a gas load. So I am very sure that's what it means, right? Like 99%. I'll just go with it, this one. And then now it's just about whether I remember the trend along group 2 and whether I can still explain them. If I don't, I'll just memorize the trend. I think that's the best way of doing it, and memorize the explanation. I'm sorry, is okay? Or you want more?
Okay, in O level, we only learn melting point, boiling point.
No. For carbonates, we learn the trend. We do. Okay, I'm going to show you the table. That is roughly what we learn in O level, right? Okay. So, carbonate. I think in your year it should still, right? I don't think there's a change.
It's just the reactivity series.
So happens that the stability trend, the decomposition trend is very according to the reactivity trend, which kind of become part of how they explain. We should put them side by side and realize that, hey, how come they trend in the same way, so to speak. So that is part of the explanation, even back then. Again, if we don't remember, we should just either go for it or remember it or memorize it or stuff. So you're saying?
I mean, at this point, they haven't talked about reactivity series yet. Like I haven't seen that in a long time.
Oh, I'm so sorry to inform you. I'm so sorry to inform you that everything you learn from pure chemistry and A math is just taken for granted right now.
Okay.
They take it for granted. E math, A math, and for you, pure chem. No? That's why I keep saying that. Really, that's why I keep saying that. They will have no qualms. They will totally expect that you can do that, at least from an O-level level, and taking it for granted that you'll be able to integrate with whatever new that they are saying. That's how it goes.
Okay.
Sorry, are we progressing? Are you still confused?
I'm just scrolling.
Right. I forgot to explain to you something about the KSP, if you don't mind.
Oh, okay, sure.
Remember that we were juggling between, the higher KSP and the lower KSP thing? We were always doing that, right? This one has a higher solubility. This one has a lower solubility. That kind of thing. Right. Then when I was trying to imagine what's happening, I imagined that at the point where you make the contact, make the drop, right? Okay. Both PPT will happen for a while because at the point of contact, the concentration is quite high at first, and then it will spread and definitely drops until only one will happen. No, the other one will not happen. You remember that?
Yes.
I was saying that. I forgot to think about what happens when things get diluted because I'm very certain at the initial contact, both will happen. So I'm trying to plug the gap afterwards. So when it becomes more dilute, I say only the guy which is less soluble will continue to precipitate. Makes sense, right?
Yeah.
What I fail to think about is that the PPT of the other guy, the other guy which was more soluble happening at the start, that guy already formed, right? A little bit of that PPT, right?
Yes.
That PPT will dissolve. The PPT will revert back to not a PPT because the concentration drops. The concentration drops. I forgot that. So that's why the first PPT will not exist. So it will happen and then not happen again, that kind of thing. So therefore, no need to worry about that.
I see. Okay.
Right. So yeah, I'm pretty sure. So only until the second PPT, which is more likely to happen, is consumed, then you will have a chance for the other guy to appear. That makes a lot of sense. Because if not, he will continually be sucked by the other one, so to speak.
Okay.
Right. So I'm making something which is they simplify lah. Right. I desimplify by not talking about this. Just don't worry about that. I suppose I'm
No,
explaining
they actually mentioned it in the answer key, but I didn't really know what they were talking about.
Did I make it harder?
No, I understand now.
Right.
They said they mentioned dilution, but I didn't understand why it was related.
Right. Okay.
Oh, there's a lot of thermal stability.
Oh, there's another one. Where?
Oh
yeah.
0.
Danman
Yeah.
High, right? Danman
Yes,
High.
yes.
Yeah. 409, right? Okay.
Just I think again. Okay.
Oh, this one, at least they tell you what's happening. We don't have to guess. So, wait, at least I think they tell you. Wait, let me think. You know what? I'm going to see whether there's a proper definition of thermal stability, or is it me that I think there isn't, right? I think there isn't, but is there thermal stability? Thermal stability of polymer. Thermal stability of water, that doesn't make sense. Thermal stability of metal, that's not what we want. Okay, it's a very weird term. Thermal stability of okay. Oh, goodness me. Okay, so I did a mistake. Okay, now that I think of it, right? Sorry, yeah. Because thermal stability or thermal decomposition, the term must include a chemical sense. It must. It does not cover what you call the physical sense. So if I just define it as from solid it become more liquid, that means melting, right? That's not thermal decomposition. I'm so sorry. So I thought about it wrongly. It's not a physical thing, lah. It must be a chemical thing, which is to say, when you up the heat, it will react not with itself. It will take the heat and change that chemically, like a chemical reaction. It's just that not with anybody else. So to speak, I've seen people. The point is there will be a chemical reaction. There'll be a chemical change. So I was wrong in implying that it can be from solid to liquid. That was wrong. So that means when they use the thermal stability, then we are considering the fact that will they change and become something else, react and become something else under heat or not. Right. Yeah, interesting. Right.
Oh, the page 470. There's a very interesting electronegativity question. So
470. Okay, I thought you said 413, but well, whatever, right? 413 also have.
No, this is the answer key. Wait, hang on, I scrolled down too low. But
maybe it's 413.
So one with the triangle.
Yeah, 413.
Okay.
You check it out. Is that the question?
Yes.
All right. So again, we're supposed to understand a new thing here, right? In exam, right? Okay. A Van Arco triangle can be used to predict the type of bonding, which is ionic metal covalent, based on electronegativity. Well, why are we not surprised, right? Electronegativity has always been related to those types of bonding. That's, I think, the new thing in A level. Right? That's why I explained the H and everything else. Right? Right. Okay, so to nobody's surprise, those are the numbers, right? To nobody's surprise.
Yes.
Oh, sulfur is near to carbon. Okay, now I know, right? Plot the CO. Yeah, I mean, just plotting, just follow, I guess. I'm not sure how to plot. What are we supposed to plot? Oh, difference in electronegativity. Okay, I'll plot, I guess.
Oh, okay.
Right. So plot between the difference, which you can, right, between C and O, right, and then the average, which what am I supposed to plot here? The average between 1C and 1O or 1C and 2O? I have no idea. I think it's 1C and 1O because I have no idea how this works. So the difference between C and O is 1.1, right? And then their average is definitely 1C and 1O. I think. The average is 3.05. That's for 1 mark, I guess. Okay, right. So you have any idea about A and B then?
How do they get the coordinates? Hang on.
I mean, look at A, right? Where's A, right? A is where the difference is very low and the average is also very low. That tells us so much that it must be.
Oh, it's difference in F. Oh, okay.
Yeah, remember we have to just read the question, right? Because it's super new, right? So A will be
covalent.
Yeah, the difference is nothing, but B is also different, nothing, right? So the only difference between A and B is the average. The average in A is very low. The low electronegativity guys are
non-polar, like ID or something like that.
Definitely mistaken. The one below H are metals. That's what I'm trying to say here. Right? The one below H in the middle too, right, are all metals.
Oh, yeah. Oh, okay.
Right? I know silicon doesn't consider metal, but whatever, those are the metals, no? Na09. So, metals, metallic bond.
Okay.
And then B, average electronegativity very high. Yeah, non-metal low. Oh, covalent bond.
Oh, I understand now. Okay.
Yeah. That is just from me reading the question.
So it's just metal versus non-metal.
Because he tells us a lot, right? The fun article have 3 things. He even tell me that's C, so I just have to choose between metal and non-metal. I'm just reading and comprehending.
My school doesn't even talk about like the electronegativity value, so this is quite new to me.
Which I find it very weird.
Yeah.
I seriously find it very weird because I find it to be very basic in explaining so many things in A level. It's you cannot ignore it. Then suddenly it appears in the question. But that's not okay. It is a basic thing. So I guess we talking about this, you should consider this not as a bonus.
Yeah.
I have no idea why chemistry class tends to ignore electronegativity. It's so easy and so powerful to use, so to speak. Okay. Right. So I'll leave Al2O3 because you can calculate, right, Al2O3. So suddenly you have the fun article and then you can calculate stuff, right?
Yeah.
Right. So that's just reading the new stuff and applying it, right? So, right. let's try one more. Yeah.
Wait, so thermal stability, right? Do I talk about the intramolecular bonds?
Let me think. Even at this stage, they don't, right? They don't. But it goes to something very simple, right? Okay. So you would again, I use the carbonate as an example, right?
Okay.
Right. You can see carbonate two ways, right? You can see them as ionic, right? Because carbonates are salt, they're ionic. So for example, Na2CO3, those are Na plus and CO3 2 minus, right?
Yes.
But carbonates are like that, right? Carbonates tend to decompose into CO2. So instead of Na plus 3 2 minus, you're left with NaO and CO2, right?
Yeah.
Right. So the nature of the the bond inside, right? The bond inside Na2CO3 is, if you see it from an NaCO3 2 minus perspective, that's very ionic.
Yes.
So it's a Na plus, which is a very strong and persistent positive ion. The actually Al3 plus is for a very, it will feel strange at first. Al3 plus is not a stronger positive ion than Na plus in many sense. Na plus is a very persistent ionic bond. Ions.
If I remember correctly, right, I think some Al compounds have covalent character also, right?
Precisely.
Yeah.
So even though it sounds like Al3 plus is a very big and strong and powerful ion, that guy tends to take covalent characteristics, which is to say he is willing to share some electrons with other people, which is to say, I already give you my electron. I want to be released of my electron, but then I want to get involved with that electron back.
Okay.
That is how Al3 plus is not a strong ion. He goes to covalent. Something like that. Right. So, but Na plus will never ever do that. Never once in his life. Right. Never once. He will just stick to be positive. Right. Now, because he does that, he will always need to pair with a negative, right? Always, right? The negative one does not matter, quote unquote. The negative ion can be weak, can be not weak. The moment the positive is strong, in the case of Na plus, the bond is strong. You only need one guy to be strong, and then the other guy will pick up the slack. It is not going to be an average in that sense.
Okay.
So, it will be a strong negative ion. Now we know that CaCO3 2 minus is a complex ion, meaning to say inside the ion there is a covalent bond going on, right?
Yes.
So the Na plus will have the effect of making the negative ion stay as negative ion, keeping it simple, because the Na plus wants to stay as a positive ion, right? So the CaCO3 2 minus, which has a tendency to break down, so to speak, will not break down. So you will never see Na2CO3 become NaO and CO2. Never. Never ever in their life. Because the insistence of Na plus, so to speak.
Okay.
The CO3 2 minus, we already know is willy-nilly one. We already know. Then you go to slightly bottom, right? In the down the reactivity series, you go to Ca2 plus. Then you realize that you learn CaCO3 does become CaO and CO2. Right? Yeah. But with a very high heat, by the way. So it's very difficult to do that, but it can do that. So in a sense, the Ca2 plus insistence is less than the Na plus insistence, right? So the CaCO3 2 minus will break down given enough heat, right? Yeah. And Ca2 plus will settle with O2 minus. Giving it like that, will settle for that. Right.
Okay.
They don't go deeper than that. That's the lattice energy doing work lah. They don't go to lattice energy at this point. I think you go to lattice energy in a very specific way. Only for melting point and only for the Hess thingy, I think, something like that.
The what?
The when we talk about the delta H chapter, the standard enthalpy of this, standard enthalpy, then suddenly a lattice energy will appear over there.
Wait, I've never seen that.
You have not talked about standard enthalpy. You have, right? Standard enthalpy of decomposition, standard enthalpy of atomization.
Oh wait, no, it's hydration.
Standard enthalpy of hydration, yeah. And then there they have to talk about lattice energy, no? When they talk about hydration. So only there it appears.
I see, okay.
But actually, CaCO3 also have lattice energy, and actually the explanation depends on lattice energy, but I never say that because the notes doesn't say that, but that is the explanation. Just want to say. The lattice can be broken, is what I'm trying to say, but the lattice of Na2CO3 is super hard to break, again, because of the insistence of Na+. Something like that. So that relates to our discussion of thermal decomposition. You don't have to quote lattice energy. Just know that that is what it is, right?
Okay.
Okay. So then the discussion of the nitrate one will also follow the same logic, something like that.
Okay.
Right. Something like that. Yeah. The part B of the question 4 also talks about thermal stability, right?
Yeah.
Yeah. So same thing, solid magnesium hydroxide decomposed when heated to form two product, and it's H2O, so quite easy to predict the other guy must be MgO, right?
Yes.
Then the variation of hydroxide is similar to carbonate. He keeps telling us that, right? So that we kind of get that it is the insistence of the positive ion which matters. They phrase it as the reactivity of the metal, so something like that, which is just O-level stuff, right? Okay, something like that. So you just have to know whether Mg is more reactive or less reactive than barium, and then you can answer already.
Okay.
Are you okay? We
yeah.
I suppose, right? Some. Feel free to continue practicing your chem or your math. Now, tell me what's your exam schedule again, so that I at least know.
Today I'm doing bio.
Today you're having a bio test. What?
I'm revising bio.
Oh yeah.
My schedule. I don't really have like a schedule, like a fixed plan. I just like have in mind what I want to finish before like a certain day. Then
no problem. Yeah.
But
no. I mean I don't mean your study schedule. I mean your exam schedule.
Oh, you mean that? Okay.
Right. I trust your study schedule. You do what you want. But exam?
I had my chem prep already. Then math is H2 chem paper 1 and 3 is on 28 September.
The end of September. Okay. The end of September. Right. Okay. Right.
Then math is 29 the next day.
And now, wow. Okay. Wow.
And then chem paper 2 is on 3rd October, which is a Monday. So I have the entire weekend to do only chem. Then I'm planning to leave chem to that weekend.
Which is, of course, a very great idea, except that you have to do paper 1 and paper 3 before math, which is very, very weird. I mean, but you know that. So good.
Yeah.
Right. Okay, I understand. So we will carry on at least until September, the end of September. Right, the end of September. Right.
What, after September, no more lesson?
No, that's not what I mean. But of course, after first thing first, we stop. You will have your lessons, by the way. You have your lesson in school. After this is promo, right? This is promo. Correct?
Yeah.
This is this. After promo, you will still have class 1. Your year one hasn't ended. In fact, year one in JC is like very long. They want to catch up with everything, right? So they also they don't give you much break one. Like they don't they just went. But traditionally, you check with your school. Traditionally, they focus on PW, or if they're greedy, PW and class load. I hope they are not greedy, because traditionally that's what you want to finish, PW.
Yes.
So if there is no class, which I really hope your school is like that, then that's why there is no tuition in that sense.
Makes sense. Okay.
And then, on the real holiday, after your PW, we do a very normal holiday tuition. Right? This holiday tuition is not a holiday tuition that you usually do, right? Because we don't ever talk about future stuff, new stuff, right?
Yeah.
I actually don't want to talk about new stuff because I want to talk about promo, because promo lah, right?
Yes.
Then after the PW, after your November, around December, I ask you your holiday plan, all those stuff, blah blah. Then hopefully we have time to do the future stuff lah.
Right? Oh, but then, if I'm not wrong, like in January, like J2s have some sort of exam also. Is it?
Again, ask your teacher, but that is dumb. I think. I mean, there's always an intention in exam. Right? Yeah. Exams are difficult to set up properly. It takes a lot of time. Then you have to mark some more. Then but they do that because they either want their student to study more, which is dependent on how promo goes, right?
Yeah.
Or they just want them to study the things that the promo doesn't include. Right. Both stems from that kind of I'm so sorry to say this, their insecurity of their students learning, right? Right. Yeah. So which I see no problem with you. You will just be learning whether there's exam or not. And you want to make sure that your learning is great whether there's exam or not. So what I'm trying to say is, doesn't bother you lah. Whatever lah.
Okay.
That exam, again, we'll definitely talk about either promo plus or simply the one after promo, keeping it simple.
Sure.
I think that's it lah. I hope your school does not do that. So you just ask lah after promo lah.
Okay.
Okay. So if that makes sense.
Oh, yeah.
Okay. All right. Then, I suppose good job today. I will see you tomorrow night. And please give your handphone to Kyoko.
Oh, okay.
Your handphone, sorry, the handphones. All right. Okay. See you then. Oh, testing. Aryan, I can see you. Can you hear me?
Hello. Yes.
Yes, hello. I can hear you also. Okay. Oh, right. Okay. Put this here. And then... Right. Okay. Oh, yeah. Okay. Kyoko is here. All right. Okay. Good. Right. So just a minute, Kyoko, Aryan, I will have some update with Kyoko first. Yeah.
Yep.
Thank you. Okay, Kyoko, how do you feel?
I'm okay now. Yeah.
Right. Okay. I don't mean the question. I mean really, how do you feel? Yeah. You okay? Yeah. Right. Pretty normal.
Yes.
Okay. All right. Then, yeah. If you feel otherwise, just feel free to tell me. Okay. So, thinking about your upcoming exam, right? I think it's at the end of September. Is it something like that?
Yeah.
Right. So how many gaps have we covered, and what are the remaining gaps for you? Let's stop and think about that for a while.
As in like the topics, or
we can say that. We can say that.
Before the holidays, my AMS teacher kind of sped through Trigo, so I don't understand that. Then for the earlier topics, the past topics, I think I'm rusty, so I need to practice those.
Correct.
Yeah. But coordinate geometry, circles, and binomials, I think I'm okay because it's very familiar to me. I just got tested for it, so it should be okay.
Correct.
The rest, yeah.
I believe that.
The rest I need more practice. Yeah.
Right. So in the case that you run out of practice paper, I probably don't think so. But in that case, then of course you can always refer to the Google Drive that I shared. Yeah. That's for more additional topics additional paper. Now, for the Trigo, let's discuss how to deal with it. Right. Okay. So, yeah, one way is to deal with it. Wait. Actually, I'm not comfortable with that. Okay, so there are two ways to deal with Trigo, yeah. All right. Okay. Because Trigo is, it seems to be new to you, right? Seems to be new to you. Although we have discussed it in holiday tuition last time, but that's a long time ago, right? You're not talking about the sine rule, cosine rule, right? You talk about the AMAT trigonometry, right?
Yeah.
Right. So there are two ways to deal with it. First thing is to simply ignore it and focus on the other topics. I think you'll still be doing very fine because I think it's not a very big topic right now. It is supposed to be very big, but they will simply continue after Sec 3, something like that. Right. So we will cover that on the holiday after Sec 3, I believe November, December one. Then your Trigo will be good there because we have a lot of time to talk about it. Trigo is not a subject that you can just talk a little bit here, a little bit there. It can be very confusing that way, right? So that's the advantage of that approach You just worry yourself with the past topics. That's one way which you have been practicing from time to time, right? You also don't need to study every topic anyway to do well in the end of year, right? That might be unnecessary if you have to balance with other subjects also, right? AMAT is not your only subject. Right? So that's one approach that you can choose. Another approach is, of course, we study Trigo as fast as possible, and then we go and practice them, right? But all I'm trying to say is, at this point, there is no need to be too greedy for perfection. Is what I'm trying to say, right? We can feel free to choose the topics that we want. Right? Because when I hear your teacher speed up through Trigo, your teacher almost never speed through things, right? Correct or not? Your teacher actually goes rather slow through things and maybe didn't cover enough. Correct or not?
Yeah.
So when he speed through, I'm guessing that, I mean, unless he give you more practices and explain more, well, how can the class be confident for the topic anyway? First thing first, right? Thing first. So I don't think he will give too much of that question in the exam. I'm guessing, of course, but if I'm a teacher, then I certainly won't feel confident giving a lot of people, right? That makes sense, right? Right. So that's what I'm thinking about. Maybe it's better to just study the past one. Right. So you feel free to choose. That's your subject, that's your topic. If you decide that we want to try to understand Trigo, then we'll use the time, the intuition to do that. It'll take some time though, just saying, right? It'll take some time.
Yeah.
Okay. So I think you should make the decision in this holiday tuition, as in this today or tomorrow. But then we at least plan properly for our tuition, after holiday, there isn't much time left anyway, correct? Right. So you want to think about it maybe today?
I think focusing on past topics better. Because like not the entire paper, I don't think it will just be 3 So
definitely not. No way, right?
Yeah.
That doesn't make sense. It really doesn't make sense.
Uh,
If that happens, then everybody will fail.
mm,
Which is like, then for what? Like, okay, then.
yeah.
So if that's your decision, you're saying?
Yeah, I think practicing at the past topics are better.
Okay. So if that is your decision, then you have freedom from Trigo lah. Like just pretend it doesn't exist, right? Like whatever lah. And also you can use the time to confront the difficult questions of the past topics lah. There's always advantage and disadvantage, right? So the advantage is that you go deeper in the past topics, simple lah, right? Or if rusty, we do this question. If you're already good, we go deeper, something like that. Right? So that's what you're looking for, no? In this, I guess, 1 month. Right. So feel free to continue to do that, because I noticed that you're doing multiple topic, meaning you're already doing a paper. So you're already going from this topic to that topic, this topic to that topic. So I sense that your discriminant is improving, but it's not solid enough yet. I think your other topic seems better. So I'll just keep answering your question because you'll just keep practicing. Right. Okay. Having said that, don't tire yourself too much and don't forget your other subjects. Okay. So for now, just for this half an hour, do you have some question to ask?
Yeah.
Okay, then you put them, right? And I will talk to Aryan first, right? Okay, the simultaneous one, you're done already, right?
Yeah.
Right, okay.
I just put in the Jamboard.
Please do. That will help a lot.
Okay.
Oh, that thing. Okay, yeah, that thing. Okay, so Aryan, again, just confirming that you don't have much homework and you don't have much practice right now, correct?
Yeah.
All right, so in general, have you thought about what you will do in September lah? The September still have 20 days lah, so have 3 weeks, correct? Something like that, right?
Yeah.
Your plan starts around October, right? October you're gonna do this, you're gonna do that, right? So in September, what is going to happen in school, and what is your general plan?
In September, there's gonna be like a night study.
Okay.
Yeah, I'm gonna attend night study, and I'm also gonna try and make a timetable, so I could see what subject I have to study every day.
Which is nice. If you have made them, just share with me. I won't do much changes. Just want to know, right? So what are you saying is that there's no normal class or what? Is that what you're saying?
No, there's. But
right.
Along with normal class, there's night study.
So it's like the school is open until night, something like that.
Yeah.
All right. So what's your preference here? Do you want to study until night at the school or what?
No, a few days I've taken it for a few, like every Monday and Friday.
Right. That looks great. That's great. As long as you don't tire yourself and as long as it is useful. Now, it's a bit of a personal question, if you don't mind. Yeah. If you mind, just don't answer. Right. Do you prefer to study, in a small group, or do you prefer to study by yourself, or well, if you're doing those night studies, what's your preference?
I mean, in night studies, you're supposed to study by yourself, but I don't mind studying a small group. Usually, people have their own preferred small group, right? Do you have your preferred small group, or better study by yourself? I mean, I do have a group. Yeah, but we don't really study that often. Together. Right. So just saying that the group matters in a sense that you don't have to be in a group. That's not what I'm saying. But you will know whether a group is inclined to, improve their study or not. Just say, right? Yeah. If the group is not inclined to improve the study,
at this point, probably not going to happen. The group dynamic is just like that one. Maybe more having fun, right?
Yeah.
I have met very rarely, but I have met a group of friends, which is very fun, but also can study together. Right? Really, really study together, but also have fun. So I can see the study part, so I never mind. But some groups will just have fun. No?
Yeah.
So it's an excuse to not study, basically, right? So I don't think that kind of group will change. So stay friends, but study together. If your group is like that, then don't do that, right?
Yep.
Right. So just saying, right? So I understand you can even construct your plan, but because when we want to construct our plan, there are two ways of doing about it. We can do it when we are very relaxed and calm, like right now, nothing much pressure, right?
Yep.
You just think slowly. Or when you're under pressure, you have to plan something, then you plan and then you immediately do it, right? I dislike the second planning. I think the first planning is usually better. So
yeah.
Right now you're in a relaxed situation. Would you like to plan your 3 weeks of September?
Yeah, I'm gonna make a timetable.
Right. You have your own style, right? You have your own preference of things and you know what's happening in school. So you do you. And if you don't mind, after a while you're done, you share with me.
Yep.
Right. So feel free to turn on the video if you so wish, right? Okay. Ainesh, I can see you. Can you hear us?
Yeah.
All right. Right. So Ainesh, how are you feeling today?
Tired, but that's to be expected.
All right. Right. Just to inform you that we have been having a lot of tuition, right? Even more, right? Yours are more than the other. On next Monday, this coming Monday, and next Tuesday, we will have no tuition. Let's just have a little bit of tuition break, right?
Monday and Tuesday.
Yeah. We have been doing a lot until tomorrow. Tomorrow we'll still be doing a lot, right?
Yeah.
It's good to take a little bit of a break, like meeting each other too much also not good one. Just take a bit of break and then we are fresher and then we see each other again on Wednesday, then we start again. Remember, your Wednesday is a holiday, so that's not a bad thing to do.
Yeah.
Okay. All right, take it as you're free to do your own stuff, right? Okay. So for today, chemistry, right? So we're back to chemistry, and I was explaining to you something that is, I think, going to happen the moment you enter school. So I guess it's good to continue with that. Any objections?
No.
Right, so prepare your worksheet, prepare your paper, prepare your video. I'll settle the Kyoko question first. Right? So Kyoko, I'm seeing your question here, right? All this stuff, right? So, and then it's a circle thingy, and it's a very weird circle question. The good thing is that he has a drawing, and I think you're using it. So what's your question? What's your problem here?
I don't know how to do it. Yeah.
You mean part 1 also? No.
Part 3.
Part 3. Sorry. Part 3. The explain one. All right. Wonderful. Yeah. Okay. So the y coordinate of D. Where is D? Oh, there you go. Okay, wonderful. So let's see what we have here. Right. So when he wants the y coordinate, he wants half a point. Okay. That's usually weird, I guess. It's weird to want half a point because it implies that we either have the x already, we either have the other half, or we're going to use this half to find the other half, right? I'm not sure what's going on. Let me check. So we have AC, correct? We have AC, right? I believe if we want to, we can find OA. So we have OA also, right? We also we also have DC if you so wish, right? We have DC if you so wish, right? So we don't have D, but this is a rectangle, right? Okay, so you know that this is a rectangle, is it? You know that, right? You know that this is a rectangle, right?
Yes.
Do we have C or not? Do we have C?
I found C already.
Okay, then we have C. Now, so we know so many things. So I believe it's time for the triangle method. Now tell me what C? Tell me what C is?
9,7.
9,7.
Yeah.
That sounds very weird. Nine comma seven.
Yeah, 9,7.
Let me confirm that that is correct.
Yeah. Yeah. C,
The
right?
line A. C, yes, yes, C.
Yeah, 9,7.
Huh, really? Oh my goodness. Right. Okay. I think I realized something here. Wait. Yeah, I don't think it's a rectangle. So let me show you. Aryan, just checking that you will be starting yourself, right? Just checking.
Yeah.
All right. So just
Paper now.
right. You can use paper, you can use computer, whatever you want, but do take care of your plan. Yeah, I want to make this bigger. So I'm still thinking. I think the problem lies with this guy. Okay, so I believe this is not a rectangle. So this is not 90 degrees, right? Why do I believe so? Is because if the circle is truly a rectangle, let's say I draw this as a rectangle, say, then I think the circle will go into the ground.
Go into what? Sorry?
It will go into the ground. So like the circle penetrates the ground because the tangent must go through like that, maybe something like that. And then it will go into the ground, right? Something like that.
Yeah.
So that's not possible, right? So okay, that's it. So I don't think that's a rectangle. So what is it? All right. So what it should be is that oh goodness me. What's the radius of the circle? The radius of the circle is √5.
Yeah.
Right? The radius of the circle is √5. So
yeah,
the place where the circle stop, it must be like this. So I know the O is here, right? The O is here. So I'm gonna delete this O just to make it not confusing. So it must be like this. A circle touching a ground must always be like that. So here's the center, and then this is the point of touching the ground. I'll call that, I don't know, I call that D prime, right? I mean, D prime is the edge of the circle, that's what it must be, and D is the center. That's just the radius.
Okay.
And this is a very straight line. So this one is 0. So this must be the √5 because it's a radius. I think the picture is a little bit confusing, even though we have drawn it. So I think that requires some thinking. So I guess that's why it's √5.
Okay.
Right. Okay, something like that, yeah? Right. Oh, sorry, Aryan, you're actually doing physics. You're not doing planning today. I'm sorry. I thought you're planning.
Oh.
You don't have to. Sorry, I was just suggesting that you will be planning right now.
Oh.
Right. You don't have to, but that's what I thought we were talking about. Right. So you're not doing planning right now?
No. I'll do it in the class.
Sure, no problem. May I know what physics paper are you doing? As in paper 2, is it?
Paper 2, yeah.
Right. So I have a strong suggestion towards physics also, which is to say your goal is, oh no, you don't care about your goal in physics. You don't care, right?
Yeah.
Okay, then because if you care that you will be A1 or A2, I will ask you to train like chemistry law, Go to section B, do section B first. Yeah, Papa, yeah. Right. But you don't care too much about that. Just to confirm.
Yeah, I'll just try to get as much marks as I can.
All right. Then you do as you do lah. Right. For Michael, I will impose. For you, I don't. Okay.
Yeah.
All right. Got it. Okay. So for Inesh, we're using the chemistry Jamboard. Right, there you go. So Inesh, please refer back to page 14. Yesterday we clarified some things, right? Okay, are you at page 14, Inesh? Inesh, can you hear me? Inesh, can you hear me? Inesh, can you hear me, Inesh? Inesh, can you hear me? Inesh, can you hear me? Aryan, just checking, you can hear me?
Yeah.
All right, thank you. Inesh, can you hear me?
Hello.
Yes, Inesh, can you hear us now?
Yeah.
Okay, all right. Go to Jamboard, please, page 14. Right. Are you at Jamboard, page 14?
Going there.
All right. So Kyoko, I think you're doing a new question, right? Because I cannot follow. All right, sure thing. Go ahead.
Yeah.
Okay, so again, Inesh, are we at page 14?
Yes.
There you go. All right. So again, look at the thing. What in this page we were talking about this yesterday. Yeah. So let's start again from this page. What are we doing in this page? Do you remember? This is new.
Oh, you're talking about precipitation.
Correct. Specifically, I'm talking about how to make a precipitate, which is to say how to make a salt. This is the salt that you actually say when I say give us a random salt, please. All right. Okay. So this one, you gave us lead sulfate. Lead sulfate is a solid, meaning it is a precipitate. As in precipitate is solid. That's the day we talk about it. Precipitate is not gas. Are you still accepting that, or you still have concerns?
I mean, I guess I'll just accept it.
All right. I'll give you more reasons. Okay. I respect the acceptance. I'll give you more reason. If precipitate is gas, how can you filter? You can only filter solid one, so to speak.
True, that's true.
Right. So I'm not saying that gas cannot happen. Obviously, gas can happen. Bubbling can happen. We don't call that precipitate. We just happen to call the solid stuff precipitate. Right. So that's what you filter lah. That's what you call precipitate. Right. Now, so happen you're making a salt which is a precipitate. There you go lah. Okay. Right. Now, I'm telling you back then, yeah, salt positive, negative, so I must make it from somebody who contain positive and somebody who contain PB and somebody who contain SO4. Make sense? This is your proposal. You propose this PbOH2 and H2SO4, and then the complete reaction looks like this. Okay so far?
Yeah.
So yesterday we go back to the solubility table. It turns out that we have to use that a lot and a lot, right? For example, I keep asking you, what is lead hydroxide? Is it precipitate or is it not precipitate? We haven't answered that. So is it precipitate? Is it not precipitate?
Lead hydroxide.
Yeah, according to the table. You may want to refresh your table one more time.
Yeah, lead hydroxide is not precipitate.
Is what?
Is precipitate.
Very good, because hydroxides usually precipitate. Then your lecture note, your worksheet say except group 1 and group 2. So we'll accept that. We'll accept that. Except group 1 and group 2. Yeah. So PB is not group 1 or group 2. So I put this as solid. Now, what's the big deal here? I wasn't trying to get marks by completing the reaction. That wasn't what I'm doing. It's nice if I can get more marks here. That's up to him. I am completing this solid equals solid liquid thingy because it is very important for making this. That is what I want to explain. One more time, huh? One more time, huh? The making of this don't just depend on the reaction, it depends on the solid or the aqueous stuff. Okay, again, let me explain. This guy, the starting guy, and this guy, the guy that we have, this and this has a potential clash. I want to explain the clash. This is a very difficult clash to resolve. Okay, very difficult clash to resolve, right? Want to explain. Now you got to use your imagination one more time. Right, my starting guy looks like this. What the heck am I drawing here? Why is my starting guy drawn like this?
Because that's a precipitate.
Which is this guy or that guy? Just checking.
It's this guy.
Which guy? No, the starting guy. If we already have this guy, then almost done. We gotta start somewhere, right? We gotta start somewhere. Oh, you gave us a starting precipitate, so I draw precipitate low. Make sense?
Yeah.
What's the liquid all about then?
That's the H2SO4.
H2SO4. So the liquid is not just water, lah. So good to know. So this is your PbOH2, right? I will not explain the very difficult clash. Very difficult clash. So if this is a solid, because it's a precipitate, the reaction can only happen at the border, correct?
Yeah.
Right. So I'll color the precipitate, which is this one. So my goal is this yellow guy. So the yellow guy only happen at the border, right? There you go. Lah. So you see the yellow forming? So far, so good, right? The yellow form and the yellow form and the yellow form, and it will now stop. The yellow will now stop forming. The yellow doesn't go more, right?
Yeah.
Basically, the reaction stops after the yellow is formed somewhat. Now, practical considerations, yeah? This is lab consideration. This is practicals, really. Is that a problem or not?
No.
It is a big problem. First of all, I might want more yellow. I want to make more. I put PbOH2 that much. So I expect everything to become PbSO4 lah. It's a reasonable thing to expect, right? But yellow happens after a while and then stop. That's a problem. Okay, I waste some material. Right? That's first problem. If I want to make more yellow, is there anything I can do? I need more yellow. Okay, it is stopping here. Why the heck is it stopping? I'm unhappy. What's the problem here? Ainesh. Why is it stopping? I want more, okay? I want more.
You just stir it.
Okay, so what happens when you stir it? Pay attention carefully. I'm not trying to make this up. This is not imaginary. So I, check, right? So what happens, right? So I break up the clump, right? I break up the clump. And then suddenly, after a while, I break up the clump. I see that, there's more reaction going on, and then suddenly I see this instead. I see that instead. And then all of this will settle down as clumps. They are rather big clumps, by the way. You like Milo? You like Milo?
Yeah.
You like your Milo, condensed, full of Milo?
I suppose, yeah.
When the Milo is too much, some of them form clumps and does not dissolve. You have to press and press and press and press to help him dissolve.
Yeah, true.
It is happening here on a very annoying scale because these two things cannot even dissolve. It will just clump one. So the clump will have yellow, your gold outside, and then your inside is still the old stuff. This will just happen. You cannot just stir out of the problem. Do you know why? Because the yellow is blocking the H2SO4 from reaching the inside. Your supposed goal, which I like, I want it, is covering the raw material, stopping the two raw material to meet from each other. And that keeps happening. Right?
Yeah.
So can we resolve this problem or not?
I suppose, yeah.
Cannot. Full stop. Yeah. We don't do it. Full stop. Because we cannot resolve this problem.
Okay.
This, whether you remember or whether you understand or whether you experience in lab. Actually, I hope that you will experience it in lab. I don't know whether it will or not. This you will need to remember. I cannot make a precipitate salt starting from a precipitate. It is starting from another precipitate. It is extremely annoying to do. Extremely annoying. You cannot resolve this coating problem. It's not practical to resolve, more like. Okay, so is this, therefore, the question goes, is this an appropriate way to make PbSO4, to mix PbOH2 and H2SO4? Is it appropriate or not?
No.
Okay, that's it. That's the first concept I want to teach. You cannot suggest this. They ask you to suggest how to make this, for example. Don't suggest this. You cannot resolve the problem. You can pretend to say, in the paper, stir it away. But everybody knows in lab, you cannot stir the problem away. So,
theoretically you can, and they'll ask in theory.
I've warned you. They are not asking for a theory. They're asking for a practical application.
Okay. Can you give a summary of everything? Just a quick summary. So.
We haven't even gone to half. This is just the start of making salt. I'm just describing a problem that you need to be aware of and must avoid. Let me just put it this way. I want to make a precipitate because the salt I want is a precipitate, right? I want to make a precipitate. I cannot start with a precipitate because the precipitate result will coat the precipitate starting point. Then the problem will never end.
I see.
Write that down if you must. This is very important to understand because if not, you're stuck with memorizing. Your worksheet does have everything to memorize. If you want that, you don't have to understand this one. But if you want to understand, then make sure you understand properly.
Yeah.
So summarize this for yourself if you so wish. Then I'll go to the next part. Okay, Aryan, I cannot follow your working. Do you want me to see your question? If you have no problem, it's okay.
No problem.
All right. Okay, so Kyoko, it's okay so far?
I am not sure.
Right. That why doesn't look like you can resolve the cert, yeah? Like it looks like you're stuck with it, yeah? It looks like it. So if everything is correct, you are kind of stuck with it. Equation decay. What is the C0? Right. That is a great summary. I hope you will understand it as a practical problem. Okay, Ainesh?
Yeah.
Now, I'm going to now tell you what can happen. What can happen. Yeah. So in all this drawing, precipitate is happening, correct? This is a precipitate, this is a precipitate, this is a precipitate. Okay. So, hey, I'm making a precipitate. So clearly it is possible to make PbSO4, for example. Do you see how we start? Look at this red color, right? What's my starting two material? The transparent liquid, correct or not? Transparent liquid. And also this, I guess, yellowish drop lah, I guess lah. So there's a transparent liquid, colorless liquid, and a yellow liquid. My point is this. Do you see any precipitate in the starting point, in the starting material?
No.
Because there isn't.
Yeah.
Look at the second drawing. I just randomly take out of internet, transparent, then I don't know, maybe they mix things, I think, because, the thing increases in height, and then you have the precipitate. So I'm clearly making some sort of precipitate here. Yeah. From the starting point of, do you see any precipitate?
No.
No. So a simple conclusion here is that, I can make a precipitate. Usually I will start with non-precipitates. I will start with non-precipitates, and I'll explain why that is a very good solution to the problem. Right, now let's try writing the reaction first. Now we're still making PbSO4, so I'm asking you to propose another starting point. I don't want a starting point which is a precipitate. Can you propose something which is not a precipitate?
Okay, sure. A salt.
Sure, we can start with that.
Magnesium chloride.
Okay, MgCl to 2 in this case is definitely aqueous. Now, this is not a good suggestion because I want PbSO4. Do you see any Pb here?
Oh, right. I forgot about that. Okay.
So this guy needs Pb. That one is fixed. This guy needs Pb. So you must start with Pb. Pb something. Must be aqueous.
So a group 1 or 2 metal.
Look, you're thinking of changing the metal. It's very confusing because if you change the metal, you don't get Pb.
Right. Yes, that's Pb.
Can you change the negative guy instead? Don't change the metal, the positive guy, because you need the positive guy.
The negative can be NO3.
NO3, right, NO3. How come you suggest such a thing? Why are you suggesting to us lead nitrate?
Because sulfate is not an option.
Why is that so?
Because it'll precipitate.
Yes, it is also a precipitate. Lead nitrate does not precipitate. Done. A very excellent proposal. Okay, we will get our precipitate. Simply put, because the precipitate that is happening, right, when you mix them, is not going to block liquids, so to speak. Liquids cannot be blocked by precipitate. They will keep mixing until happy. Right. So let me ask you another practical question. Yeah? Ainesh, we have our precipitate in the cube lah. We mix two clear stuff. We get our precipitate. The color is white, so it looks like this one. PbNO3 does look transparent. H2SO4 does look transparent. This is our PbSO4. Okay, contain here. Is this the end of making a salt, or is this the start of making a salt?
It is the end.
No, this is the start.
Oh, okay.
Now look at your lecture, your worksheet, and I will point out what do I mean by this is the start of making a salt. Right. Yesterday, you have a worksheet or some sort of a spreadsheet from your teacher. Okay, let's look at that.
Oh yeah, can we take that out?
Aryan, are you okay so far?
Yeah.
All right. Kyoko, are you okay so far?
No.
Right.
I looked at the answer, but like it's different.
Still the same question, I believe.
Yeah.
All right. Then, is it the part 4? Is it?
Yeah.
Right. So agreeably, you know the radius, but you need point D lah, right? You do need point D. Right. So, oh yeah, point D is challenging. That one I agree. They have no lack of creativity in finding this kind of questions. Definitely no lack of creativity.
I tried using the equation of the circle, but I don't think it.
No. How can you find the equation of circle by using the equation of circle? How can you do that, right? Okay, now, so I think, first of all, you have to concentrate on finding D instead. And it's only the other half of the point. The other half of the point. Now, remember what I say to you. Remember this when things are hard. If you want to find a point, you need two things. What are they?
Well, one half of the coordinate and a line.
Yeah. Do you have that option? One line and then why are you not using it?
Okay.
Right. Okay, give it a try. Give it a try. So, Ainesh, did you find it?
Sir, do you see something? I'm finding it.
I think it's right in front of you, I think the paper slip between your foolscap is the paper of yesterday. I think that is the paper, right? Let me see.
Found it.
It is the paper, right?
Yeah, this is.
Yeah, okay. So I'm gonna ask you to flip. This is not the page I want. This is just the acid and the base, right? So flip it. Let me see the other page. Okay. Look at that method of salt preparation, right? You're gonna now understand the second box, right? The method of salt preparation, whatever, precipitation, titration, and everything. Okay.
Okay.
Right now, I will look for what we did just now. Look at that. So look at third row. Third row is nature of salt form. Nature of salt form. Do you see that? The nature of salt form to the right, insoluble salt. We even have the PbSO4. See? Just nice. Okay, so the nature of salt form is insoluble salt. If you move to the right, it is soluble, correct? So if you want to make insoluble salt, he's saying whatever this thing is saying, you have to precipitate. Look on top, you have to precipitate it. Understand?
Okay.
And if you look down, you will receive a very short explanation. The salt form is insoluble. Yeah, I know lah. I want to make insoluble salt. I know that. But look at number 2. The starting regions. The starting regions are? Ainesh, reading please. Ainesh, can you hear me? Ainesh, can you hear me?
Yeah, I can. The Wi-Fi just cut off for a second there. So what are you saying?
Read the box below the insoluble salt, right? Insoluble salt, right? We want to make insoluble salt, right? The method is precipitation according to the top column, right? Precipitate, right? Yeah. Nature of the starting region, both soluble in water. We just concluded that. Then go down. Salt form is insoluble. Is that a repeat or is that a new thing? No, it's a repeat because you already know you want to make an insoluble salt, right? Right. I don't know why he's just repeating stuff. Now, number 2, starting region are both soluble. Is that new or did he just repeat himself?
New.
New or repeat?
New.
No, he just repeat himself. Look at the top, both soluble in water. I don't know why he's repeating himself, but that is according to what we talked about just now.
Okay.
You just understand the first column, even though it's very repeating. Are you okay or not?
Yeah.
Now, does the second column, the precipitation column, does he explain why we must use both region as soluble? Why must we do that? Does he explain? Kyoko, move up, please. Ainesh, did we kena cut off again? Ainesh, did we kena cut off again?
Oh, no.
Okay, my question is, the second column, precipitation. Did he explain why the region must be soluble, both soluble?
No, he shouldn't explain.
Okay, did we explain it?
Let me check the table.
Did we talk about it just now?
Yeah.
The reason, right? You're very clear of the reason. The reason is what you wrote. Yeah, if I start with a precipitate, the coating problem will never be get rid of. You will always be stuck with that problem. Looks like your summary is not. Maybe they explain it in another situation. Now, I would like to say this very carefully. The summary doesn't explain the reason why you have to choose the both regions soluble. I am very sure in exam, you need to know why. Not because they will ask, but so that you will avoid the wrong answer. I'm very sure of it. So that's why I bother explaining it to you. Okay? So this summary doesn't contain the reason. I think you must remember the reason so that you can avoid the wrong answer. Okay? At least say if it is okay or not, or if you are too tired, we can take a rest.
Yeah, it is okay.
You okay? For the precipitation column, you really okay?
Yeah.
Right. We only have to understand the third column and the fourth column.
Okay.
Right. If we understand that, then we are kind of ready to look at question 7, 8, 9 yesterday. Okay. Now, kindly read the third column, titration, and then the fourth column, that long stuff. Okay. And then let's discuss what you don't understand. Okay. Please do so. Now, Kyoko, are you okay or not with that question?
Yeah. Okay.
So the half point and the line method solves the problem, correct? Like, what was your doubt just now? What was the problem just now?
You didn't see that.
Right. I strongly suggest that you think about that when you face a problem. In fact, even before you face a problem. Because that's how I think. I want to find a point now. Oh, okay lah. Do I have one line? Do I have another line? Do I have half a point? Then I usually solve my problem 90% of the time. Right? In exam, it will be very good for you if you can think like that. Aryan, are you okay so far?
Yep.
All right. So, Ainesh, have you finished reading somewhat? Oh, I forgot, Kyoko, you're doing more than half an hour, or you're doing almost 1 hour. That's fine with me. That's fine with me. Right? It's actually fine with me. There's nothing wrong with that. If you want to do continue, then the night one can be shorter, right?
Okay.
Right? That's totally up to you. What you want, you do, right? Because you don't. I'm glad that you're not sick. Okay, Ainesh, are we ready to discuss? Have you read somewhat?
Oh, music, yeah.
All right. So first, please tell me what is the similar stuff lah. What is the same? Which part is the same between column 3 and column 4? Please tell me. Right. You should notice something the same with both. Aryan, okay?
Yeah.
All right. Ainesh, nothing is similar between both? Nothing at all? Column 3 and column 4? Ainesh, is the headphone problem again? Can you hear me? So headphone problem again? Can you hear me? Can you switch headset, please?
Okay.
Can you switch headset, please? I'm sorry, this is very annoying. Please switch headset.
I was just trying something new. I'll just revert back to the regular, which is just using my laptop.
Yeah, please do. Please do. This is not fun. This is not fun. Yeah, please do.
I'm sorry. I'll just even.
I don't like this communication style. Yeah.
Yeah.
Minimum maximum. Oh, Kyoko, this is a 3-go question.
Oh.
I mean, it's directly trigo, and you have to sketch. And I'm not even sure your teacher have teach you sketch. Cannot be like that. Not be that fast one. Cannot be. That one is also trigo, the triangle one. However, maybe the triangle one you can use your EMAT trigo. Maybe, I don't know lah. Maybe you can try, but the sketch trigo one, just skip that lah immediately.
This part also skip, right?
That part must skip. That must skip. If you're interested to know, then you tell me lah next time. It's okay. Can still explain one, but yeah, this one, I don't know. Is it possible to use EMAT trigo here? Maybe possible. Maybe possible. If you want to try, maybe you can try.
Okay.
If this is what your teacher teaches, these are two different types of question.
Yeah.
No way, man. He's rushing too much. No way. No way.
Oh, sorry, my dog.
No problem. No problem. Aryan, are you okay? Aryan, are you okay?
Yeah.
All right. Aryan, actually, I have one question about listening comprehension. Can I ask about that?
Yeah.
The English one. Now, in listening comprehension, you go in the booth, is it? The table, and then a teacher will tell you a story. Am I correct?
Yeah.
Is that how it goes? And then you're supposed to respond and also kind of continue the story or answer the question on the spot. Am I correct?
It's a paper.
It is a paper. Oh, but you're supposed to listen to the article. Listen.
Yeah, it's like a recording. They'll play the recording.
Oh, right. Okay. And then I will have to. Okay.
Yeah.
Okay. All right. Understand. So my question is more like this. Is there any English paper, right, or any other paper where when you start doing the paper, you already have to prepare certain answers or certain composition in your mind, certain ideas already, so that when you enter the paper, you will need to write that kind of prepared article immediately, kind of.
I think to a certain extent, paper one, because like
I
need to prepare a certain template in my mind, like how to write, like the format of writing, kind of like that.
You mean paper one English? Paper one English, right?
Yeah.
Are you referring to some sort of formal letter writing or something?
Yeah.
But you still need to read the question, because the question will tell you the context or the situation, is it? And then you write according to the format, something like that. Now, that usually doesn't count as composition, right?
This situational writing.
Situational writing, all right. Okay. Now, is there any other section or subject or whatever that is kind of like that? Like history or SS, I don't know. Is there?
Yeah, history, I think so, yeah.
In what sense, if I may know?
Oh, like need to know the type of question. Like you need to remember how to like answer the question. Like what's the format of answering the question? Same for SF.
You mean the format helps a lot? Something like that?
Yeah. If you write in any other format, you won't get the mark.
Oh. You mean you will be marked according to the format?
And the content inside. Yeah.
The content is what you read in the paper. The format is what you must know beforehand.
Yeah, you must know. Yeah.
All right. Okay, understood. So history and SS is like that also. All right.
Yep.
Now, is there any other writing stuff, that you also must have a content already in mind?
Chemistry.
Chemistry? What do you mean by that?
Because you need to know the content beforehand. You need to remember the topics.
Oh, that's what you mean. Okay. Okay, I understand. I can understand. But not in humanities, right? In humanities, it's more like a format instead of content.
For history, you need to remember content though.
There is another section where you also need to remember content.
No, it's not a different section. It's just there's two sections to the paper. One is like a form-based question.
Okay.
That's where I need to remember the format, and I need to also write like the content that I remember.
Which is what you will refer to as I need to read before the exam.
Yeah.
I need to read this content and that content, and it may or may not come out. They will choose one or which one of the content to come out. Is it something like that? Is that how it works?
Yeah.
But I have to read more than one content. Maybe I have to read 3 or 4 contents to be prepared. Then if I am unlucky, then the weakest content I have will come out. Something like that?
No, but then we'll have to spot questions as well. Like the teachers will spot questions like this chapter came out last year. So probably this chapter will come out. It's like
they take turn.
Yeah.
It's a chance thingy lah, but it's kind of high chance. Yeah. So you put emphasis more on the other content reading. This content maybe not so much.
Yeah. That's like that.
Right. Okay, understand. That's history lah, right? That's history. How about SS? Just asking.
SS, you don't need to remember the content for the first section. Then the second section, you need to remember.
So it's not just remember content, but you also must write it out lah, in some sense.
Yeah.
All right.
Yeah.
But English, besides English you don't need to remember a particular content, right? For English.
No.
I understand. All right. Thanks for telling me. Right. All right. So Ines, again, it has been 10 minutes. Okay. So Kyoko, I'm assuming that you're continuing, yeah? Right.
Yeah.
Okay. All right. So can you move up a little bit so I can at least follow your, okay. What will you do? You will find the angle ABC. Right? Okay. So I'll put some emphasis, Kyoko, on the A-math habit. A-math don't like estimate number if you can give them exact numbers. So they don't see 0.785 to be so important, but don't erase it. You may or may not need it, you yourself. But they would really prefer that you solve the pi minus pi over 2 minus pi over 4. They will really prefer you to do that instead. That means the answer should have been pi over 4, because that's pi minus pi over 2 minus pi over 4. Do you understand? Does that make sense? So you must write down pi over 4 for them. 0.78 might be something that you yourself need. So that's up to you. But they need to see pi over 4 if it is possible. If it is ever possible to be exact. Right? Another thing I note is that because this is not using a calculator, so by right, you cannot get 0.7854. Correct or not? Because you quote unquote cannot use a calculator. Nobody say that you cannot, but you cannot use it in your presentation. You understand what I'm saying? Right? So like it or not, you must write pi over 4 because that is quote, not using a calculator.
Okay.
Right. So, but the 0.785, as long as that's not your final answer for them, you can put it somewhere for your convenience or for your own usage. So that's up to you.
Okay.
Right. There are some situations where you need to see the decimal, but I'm not sure whether this is the one. So, Ainesh, right? Ainesh. Kyoko, are you facing some discomfort handling the pi?
Yeah.
Okay, here's my simple suggestion. Now, pi is of course not an x, meaning it's not a variable. It's because it's a known value, right? But treat it like x. Treat it like x. So in a sense, imagine for a while that this is x over 4 divided by 5 times 2, right? Just imagine that for a while. So what will happen if it is, x over 20 times 2? It will be, what will you do? Again, you can use calculator if you so wish, right? Okay. Now, this is, of course, correct. This is, I pretend, 2x over 20. Make sense?
Yeah.
Right? This is 2x over 20. Now, should we stop here? We should not stop here. We can simplify. Right. Now, 2x over 20 is, of course, 1 over 10x. Correct? Of course. Right. And then you have, I hope it's not more confusing. I find it easier if I imagine pi as x, even though it is not. Now, I'm very curious on why angle CBD is divided by 5 times 2. Why is that so? I cannot see the picture, so if you can explain to me using the picture, or if that's your reason. Angle AB, sorry, which one are you looking for?
Angle CBD.
CBD, okay, CBD, and you already found ABC. Okay, sure. Oh, you are absolutely wrong like that. The angle is not the ratio. That's just totally wrong. I wish it is correct. That does not happen.
Okay.
The angle will not follow the ratio. Absolutely not. So I think your ABC is definitely fine. Definitely. Your CBD is not. CBD. It's just totally wrong. You cannot use the ratio that way.
Okay.
Right. Now I'll remind you a few things. Yeah. So pi over 4. I think it is much more useful to know the degree. Because what? Because you are very comfortable with degree. Correct? Now, nobody say that you cannot change radian to degree. What they want is that the final answer, if there is a final answer in radian, it must be in radian. That's what they want. Nobody say that you cannot work in degree if you so wish to. It's just that they want exact value answer. That's another requirement. So I'm telling you all this because see, 90 degree equals to pi over 2. You're already changing from degree to radian. Right? Because you started with degree. Why? Because we're comfortable with degree lah. I mean, we admit that lah. Yeah? It's difficult to change overnight. So I'm saying to you, maybe you want to think about pi over 4 as degree. So look, you have pi over 4 radian, right? Why didn't you say this is pi over 4 radian or something degree? It might help you think. That is, or right. Okay, this is 45 degrees. So just saying. I want to highlight another thing. We're still using EMATH, right? There's no AMATH here, so to speak.
Yeah.
It's almost as if you did not notice that the big triangle is isosceles. Almost as if. Because it's 45 and 45.
Yeah, I didn't consider that.
Yes. I'm not sure because of the radian or because you are worried that you don't know something from AMATH, but that is, I think, a very simple and important thing. It's very important. Because back to the ratio, I think the ratio you can now use to your advantage. Right? That's 2u, 3u, but it's isosceles, right? So, I think the side AB is also something that you know now because of isosceles, right? So I think it is important to notice that it is isosceles. Right, that's why at least I believe it is so. Right? Now, I'm still referring to EMATH. In EMATH, we tend to stick to 90-degree triangles, even though we can handle non-90. Okay? Well, this happens to be a 90-degree triangle. So I tend to stick to it even through AMATH. 90 degree is just easier to work with. So I'm not going to think about sine rule too much yet, because maybe I can, but I just like 90-degree triangles better. Now you notice that there are two 90-degree triangles here, the big one and the small one. Right? So the small one, do you notice that for the small one, you can already do something? Because the small one is, of course, 90 degree, and you now know it is 3u and 5u. You can assume that 3u is 5u is You can do that. So in this 90-degree triangle, you know 3 things. That's very good, right? How can this small 90-degree triangle help you with angle CBD? Is it possible to help?
Yes.
Okay, then use it. And I think based on EMATH also. I don't think there's any AMATH here necessarily. Aryan, okay so far?
Yep.
All right.
There shouldn't be a problem anymore.
Okay, Ainesh, I'm glad that you are back.
Yeah.
Okay, you got it? You got it? Okay, now that took 15 minutes, yeah? That took 15 minutes. Can we from now on just use this headset?
You should.
Yeah, I do lose my voice for this lah. So I don't want that. I don't want that.
I understand.
I don't want to make the communication difficult between us. That's not going to benefit anybody. Yeah, right. Now I can hear loud and clear, so I like that. Now we have to catch up. All right. So column 3 and column 4. My question to you, I repeat this for the 4th time already. Sure. What is similar between column 3 and column 4? Tell me immediately.
Column 3 and column 4.
Yeah, what is similar between them? The content of column 3 and column 4. What is the same?
The salt form is soluble.
Right. The salt form is soluble salt. That's just a repeat, isn't it?
Yeah.
Right. What does this mean? It compares to the insoluble salt to the left. I mean, there are only 2 types of salt, right? To make, we either make an insoluble salt or soluble salt, at least according to them. Correct or not?
Yeah.
So what does column 3 and column 4 mean? Column 3 and column 4 is saying to you, there are 2 ways to make soluble salt, but there is only 1 way to make insoluble salt. For now, that's already the meaning of this weirdly structured table. I've never seen it structured this way, but you can see that that's what it means, right? The insoluble salt only have 1 method because, for example, the other method is not worth it, too much trouble, cannot solve. I explained to you just now. Okay?
Yeah.
Let's understand the 2 methods of making the soluble salt. It seems that we have more options. Do you see any other thing which is the same between column 3 and column 4?
At least 1 starting region is soluble.
You are absolutely correct. You are absolutely correct. You must at least start with 1 soluble. Then the other guy can be soluble or insoluble. Right? To summarize, you're already getting the gist of it. Right? Now, which one do you think, just between what you know, just between what you read, which one do you think is easier practically? The guy soluble become soluble, or the guy soluble insoluble become soluble? Which one is easier practically?
The reaction one, the one it's soluble insoluble is easier, but I'm able to do soluble faster because I've done titration before.
Absolutely, your answer is absolutely correct, and then you contradict yourself. You can do titration. You must be able to do titration.
Yeah, I mean,
you should know that titration is a very slow process.
Yes.
It's annoyingly slow some more. And you have to repeat, you go and bang your head low.
Yeah.
Right? So you are right. The 4th column is the easier method. Practically, I mean. Practically. I don't mean when exam you write which one's the shorter. The shorter one seems to be the titration one. The longer one is the 4th one. But practically, the 4th one is better. Much better. Now, why is titration slow? Please tell me.
Because to get the they have to put in the exact amount of.
Precisely. Just over a bit. Then you keep flip-flopping between this and that.
Yeah, to strip it.
Right. So you know the word titration means I have to be exact.
Yeah.
That contrasts very well with column 4, because in column 3 they never say exact. They assume that you know titration means exact. So good that you know it's super slow. It's super annoying. Column 4, they say excess insoluble reactant. So note that the one insoluble is the one which is excess. You cannot, they are implying to you, hey, the excess is not the soluble, explanation follows, right? But they are saying to you that. So this excess insoluble reactant, Is that a good news practically, or that's not so good?
A good news.
It is a good news. Why is that so practically?
So that all the acid is reactive.
Yes, when the insoluble is excess, the other guy will be used up. I'm still asking a very practical question. Why is the insoluble can be excess? I find that very convenient practically. Why? Yeah?
Because it's not. It doesn't affect the solution. It's insoluble.
Well, first of all, it is solid, right? But I'm focusing. Solid is easier to handle than liquid. I totally agree with you. However, I'm focusing on the word excess. So solid easier to handle. Agree. How about the word excess? Is that troublesome, or is that convenient, or is that whatever, man?
It's convenient because it just ensures that all the acid is reactive and can just be filtered easily once it's excess.
Precisely. Yeah. So don't have to measure too much lah.
Yeah.
Just make sure there's more left over lah. Excess already what? Again, compare that with titration, no? Like the one being titrated has to be the exact same thing as the one doing the titration, kind of ish. But you have to titrate, and then have to stop at the right moment. Which is why you use indicator lah. Which is why there is an indicator lah in the titration method lah. But you know all this. So again, the excess insoluble reactant is very convenient. It's just longer in writing by around 2 sentences. Like when you have to describe this, this is almost vomiting the procedure because laboratory procedure is very standard, right? You do have to memorize this like almost exactly lah, because they will ask that in exam. They are somehow obsessed with that lah. Okay.
Yeah.
So if you already understand the basic comparison between the 3 columns, you're already at a good start because you will avoid choosing the wrong starting point. Right. Okay. So let me ask you another question. Now there's a combination possible here. Both starting reactant insoluble, right? So I'm saying that as a theoretical possibility. Is that a practical possibility?
No.
And why is that so, practically speaking?
Because none of these 3 methods have such a...
No, I mean practically, if I want to react a solid with another solid, why is that just not practical at all?
Because it's just not dissolved.
Yeah, if you don't dissolve, how can you meet properly? If you cannot meet properly, how can you react, and so on and so forth lah?
Yeah.
So you never see insoluble with insoluble. It's either one must either be soluble so that the meeting is proper lah, so to speak lah, right? Okay. Now, you still have to understand the procedure, but I think that's the easiest thing to understand, I feel, even though it's long, right? Understanding was what I discussed with you just now. What is practical, what is not practical? What's the practical limitation? What's not okay, what's okay? Right, so now, propose a solve to make, please. Which is now, sorry, which?
Has to be soluble.
No, that's up to you. You are proposing.
Okay.
Okay, so you're proposing to make?
Yeah, okay. A soluble salt, which is...
Aryan, okay?
Yeah.
All right. Kyoko, okay? Okay. All right. Right. Okay. So Ainesh, again, your proposal?
Okay, so acid H2SO4.
No. Propose the salt first. The salt to make first.
Oh, to form.
The goal.
Oh,
the
okay.
goal. Yeah, the goal first. Yeah, the goal first.
Okay. Sure. Calcium sulfate.
All right. Which you will confirm it is soluble or insoluble?
Is insoluble.
Yes. So, well, I would like to ask for you to make another insoluble salt anyway, but just be careful that that is insoluble. I'm glad that you realize that. Please propose another salt to make, which is soluble.
Okay. Magnesium sulfate.
All right, wonderful. Now, propose your starting ingredient and hopefully your proposal is correct. Please, in page 15, right? You can write in page 15, but I suggest that you write in paper instead, consulting your table. Now, Kyoko, are you okay so far?
I don't know how to. Yeah,
right.
It doesn't look the same at all.
Right. So let's say that your idea is correct, right? So I'll give you some encouragement first. Now, first of all, 8.5 is 17 divided by 2. So there is some possibility here. Some, right? So I will pretend that you are correct. I don't know whether you're correct or not. So I'll pretend you're correct and I'll try to work it out. Okay. What do I mean by this? Page 12. Now, Ainesh, I'm waiting for you to write on your piece of paper. Right?
Oh, I'm writing on the Jamboard.
That's fine. That's great. Okay, so I'm just going to work out this guy, right? In page 12, yeah, sine 5.3 over root 8.5. So now this depends on your cert, right? This depends on your cert, right? Now, special angle, sine 45 is half root 2. Do you remember that? I at least teach you this.
Is what, sorry? Yeah.
Half root 2. Now, this one, at least you need to know, at least you know this part, right? If you don't know, then I'll ask you to look at the, memorizing part. Okay? Right? It is to be memorized. Now, he gives me the goal of 17. So, well, I already noticed that root 8.5 is root 17 over 2. At least I will start with that also. Okay. So I have this weird thing aiming towards my goal. Something like that. So far, so good? Okay. Okay. This is a weird thing, but at least I'm starting, I think, quite well. At least I am trying for 17. Understand?
Wait, sorry. What? This. Why is it slash root 2?
Root 17 over 2 inside is equal to root 17 over root 2. Is this okay? This is back to the cert because I don't know how good your cert is. Okay, it's okay. Yeah. Now this is still very complicated, so I'll just process it slowly. So I'll just process it as this is a fraction divided by another fraction. That's what it is, right? Which is going to be a fraction times fraction, right? Fraction times fraction, something like that. Okay. It is going to be 2 over 2 root 17, correct? Which is currently 1 over root 17. Okay, that comes out quite nicely. So far, so good? This is not the end, but this is so far, so good, I suppose. This is purely cert, yeah? You consider your cert carefully, yeah?
Yeah.
Okay, clear?
Yeah.
Now, what he wants is that the denominator is 17, not root 17. Okay, I'm clear of that. Can you apply your cert to do what he wants? Good, Ainesh. So you're making a soluble salt using soluble plus soluble, correct?
Okay. One has to be insoluble for us.
What? What do you want, right? What do you want? Do you want to use the soluble and soluble or the soluble insoluble method? I mean, in theory, you don't have to do the titration. So who cares about the practical inconvenience, right? Yeah. It's just that in practice, you do have to care, and this will happen in your practical. So I'm discussing both sides. In exam, well, you have your preference, but in practical, I'm very clear of my preference. Now, this is not a practical. This is an exam. Just be aware that you choose the soluble plus soluble method, okay?
Yeah.
Therefore, you must, in the process later on, mention this is titration and mention the indicator. You must.
How do you know that this is the soluble plus soluble?
Well, you propose sulfuric acid, right? It is soluble, right? You also propose magnesium hydroxide. According to your solubility table, magnesium hydroxide is group 2 hydroxide, which is soluble. So you decided that this is soluble. It's not that we know. You decided. You have an option. What?
True.
You can choose the other option. Feel free to try the other option. Because you know what? I'm a lazy person. I just do Mg plus H2SO4, Why don't I just do that, man? I'll get what I want also. Wouldn't this work? Wouldn't this also work? This is Tesla. I have to say that this is excess, and then I'll get this as a H2. I just have to write the reaction properly.
Yeah.
My point is, I can choose sometimes in exam, and sometimes I will just choose. Now, I like this one better because it's just the practical method, so I just go for that. That's just my preference. Okay, I have to write a few more steps below, which is what you have to memorize. Okay, do you understand the dynamic of this salt making? There are some options. There are.
Yes.
Right, now make your soluble salt, please. Right, so Aryan, okay.
Yeah.
Now you have been practicing physics for 1.5 hours. How does it feel?
I feel like it's getting a bit better.
Okay, as long as you compare it with the answer key, because you haven't consulted with me, one time. So just making sure you're okay,
Yeah.
All right. That's is the end of the one. At night we'll continue with the AMF one.
Yeah.
Okay, it's gonna get more intense at night, so hopefully you are alert for it. Yeah.
Good. So now we're going to AMF.
I'll see you at night.
Yep.
Yeah, in general. Just continue with that trend. Right. See you.
Yep. Bye.
Bye. Yeah. Okay, Ines, you're gonna finish this part first, right? Okay. So Kyoko, have you given them what they want?
I found the answer and it's correct, but I just need to write it down.
All right. So the answer is root 17 over 17, is it?
Yes.
So your method is correct It's just that the final part, the cert, you need some help, correct? Right. You need to write down. I understand. Do you want to see the shorter method? Still EMAF one.
Sure.
Right.
Okay.
So I'll show it to you, and then you compare the method. It's not that one is better than the other. This is your study, right? This is your study. You compare properly, yeah, and then you learn what you want to learn, right? Now, I'll show you the method. The method will be the same. I have to do the ABC equals to root 4 over 5 first, right? And then this for our convenience, this is just 5, right? And I will have to take note that this is also 5u, and this is also 3u and 2u, right? So in this method, I'm aiming for this guy so that I can find this guy. Understand? Okay. That's what I'm aiming for, right? So again, I'm using Pythagoras on the small guy, right? A small triangle. So no, I don't need Pythagoras at all, right? I don't need Pythagoras at all. So I can say something like this. Tangent alpha is going to be equal to 5u over 3u, right? Which is 5 over 3, correct?
Yes.
Hey, wait. I'm so sorry. I need the sign. No, I need sign. I need to find sine alpha. So I have to have this Pythagoras. So the Pythagoras here will be root 25 plus 9 root 34u, correct? So sine alpha will be 5u over root 34u. Okay. I'm sorry, the u is something like that. So 5 over root 34. Can yeah? So far so good, yeah?
Yeah.
Right. Okay, then noting that alpha is equals to 180 minus beta, therefore sine alpha equals to sine beta. That's what I'm using for. Okay, so sine beta is also 5 over Is that what I'm looking for? Oh, I'm looking for CDD. I'm so sorry. I cannot do that. I'm so sorry. I thought I'm looking for this. I'm so sorry. That's my mistake. I'm so sorry. I looked for the wrong angle. That's my mistake. My goodness.
It's okay. It's okay.
Sorry.
Wait, Mr. Philip.
Yes, Anish?
I need to go soon because my tuition's in like 20 minutes.
Yeah. All right. So we'll talk about this more in the sense that we do the question after this, right? The 7 minutes, right? I'll see you later then.
I'll see you. Bye.
All right. Bye. Okay, right. So, okay, Kyoko, might as well we end first, and then I'll show you the method. Right?
Okay.
Okay, bye.
Bye. Wait, I come
Yes.
back now.
Oh, sorry. You still have half an hour left, basically. So if you want to come back today or tomorrow, it's up to you. If today you come back for half an hour, I'll show you this thing and you just do that. Right?
Okay.
All right. I'll see you then. Bye.